Hey champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So in today's session we are going to discuss physics questions from NEET 2015 re-exam and we are 45 questions here. So let's start the session. The first question is from the chapter Units and Dimension and the question is, if dimensions of critical velocity of a liquid flowing through a tube are expressed as eta to the power x, rho to the power y and r to the power z, where eta, rho and r are the coefficient of viscosity of liquid, density of liquid and radius of the tube respectively, then the values of x, y and z are given by. Okay. So it is given that the dimension of critical velocity is equal to eta to the power x, then rho to the power y and r to the power z. Right. Now what will be the dimension of critical velocity? It is also a type of velocity, so its dimension will be Lt minus 1, same as that of the velocity. On this side, what will be the dimension of eta? From Stokes' law, we know that force is equal to 6 pi eta Rv. So eta will be equal to force by 6 pi Rv. Right? 6 pi don't have any dimension. Force has the dimension ml t minus 2 and R means L and V means Lt minus 1. So on solving this, you get m L minus 1 and t minus 1. So this is the dimension of eta. So let's put this value here. This is m L minus 1 and t minus 1. So it has the power x. It has the power x. Then we have rho to the power y. So rho means density. We know that density is equal to mass by volume. Mass has the dimension m and volume has the dimension L3. Okay, or L cube. So it is equal to ml minus 3. So in place of rho we can put ml minus 3 and it has the power y. Then r to the power z, r is the radius, so it will have the dimension L only. So L to the power z. Now if we open the bracket, we get m to the power x, L to the power minus x, t to the power minus x. Right? And then here we get m to the power y, then L to the power minus 3y. And then we have L to the power z. On the left hand side we have Lt minus 1 only. What is the power of m? M is 0, okay, on the left hand side because there is no m. Now we can just compare the powers on left hand side and the right hand side, but before that let's find the total power on m on the right hand side. It is x plus y. So total power on m will be x plus y. Total power on L will be minus x minus 3y plus z. Right? And the total power on t is minus x only. On the left hand side we have Lt minus 1. Now let's compare. So for t, what is the power on the left hand side? Minus 1. And what is the total power on the right hand side? Minus x. So we can say that minus x is equal to minus 1. That means the value of x is equal to 1. Okay. Now we have got the value of x. Similarly, we can find out the value of y and z also. So let's see for m now. For m, the power on the left hand side is 0. Okay, there is no m on the left hand side. And on the right hand side, we have x plus y. So x plus y is equal to 0. And we know that x is equal to 1. So y will be equal to minus 1. Isn't it? So we have got the value of y also. Now we have to find z. Now for L, the power on L on the left hand side is 1. On the right hand side, it is minus x minus 3y plus z. So minus x minus 3y plus z. It is plus z, okay? Equals to, on the left hand side we have 1. So the value of x we have seen it is 1. The value of y is minus 1. So if we put these values, we get minus 1. Then here we'll get plus 3. Okay, because 3 into minus 1, minus 3 into minus 1 will become plus 3. So plus z equals to 1. So here we have minus 1 plus 3, that means 2 plus z equals to 1. So according to this, z will be equal to 1 minus 2, that means minus 1. So now we have got all the values. X is equal to 1, y is equal to minus 1 and z is equal to minus 1 again. So 1, minus 1 and minus 1. Option C will be the correct answer. 1, minus 1 and minus 1 are the values of x, y and z respectively. Next question says, if vectors vector A equals to cos omega t I cap plus sin omega t j cap, and vector B equals to cos omega t by 2 I cap plus sin omega t by 2 j cap are the functions of time, then the value of t at which they are orthogonal to each other is. So orthogonal to each other, that means the angle between them is 90 degree. So for them being orthogonal to each other, the dot product should be 0. Okay. Vector A dot vector B should be equal to 0. So first let's find out vector A dot vector B. So vector A dot vector B is equal to cos omega t I cap plus sin omega t j cap. This is vector A dot vector B, that means cos omega t by 2 I cap plus sin omega t by 2 j cap. Okay. Now if we solve it, we get cos omega t by 2 plus sin omega t by 2. You know how to find the dot product? Now you can see that this is in the formula, this fits in the formula cos A cos B plus sin A sin B, right? Where omega t is A and omega t by 2 is B. Okay, omega t is A and omega t by 2 is B. And we know that cos A cos B plus sin A sin B is equal to cos A minus B. So in place of this cos A cos B plus sin A sin B, we can simply write cos A minus B. So cos A minus B. So A is omega t and minus B is omega t by 2. And on the left hand side, it will be 0 because we know that if they are orthogonal, their dot product should be 0. So cos omega t minus omega t by 2 is equal to 0. So let's write it like this. Cos omega t minus omega t by 2 is equal to 0. So we can say that cos, see, omega t minus omega t by 2 means what? It will be equal to half omega t. So cos omega t by 2, cos omega t by 2 is equal to 0. So we can say that omega t by 2 is equal to pi by 2. Okay. We know that if cos theta is 0, see, cos theta is 0, that means theta is equal to 90 degree. So here cos omega t by 2 is 0. So that means the omega t by 2 is equal to 90 degree, and 90 degree means pi by 2. So from here we can simply solve. 2 will be cancelled and the time required will be equal to pi by omega. So the time for which they are orthogonal to each other is equal to pi by omega. So let's see. Option A will be the correct answer. At time t equals to pi by omega, they will be orthogonal to each other. Option number A is the correct answer. Next question. The position vector of a particle vector r as a function of time is given by vector r equals to 4 sin 2 pi t I cap plus 4 cos 2 pi t j cap, where r is in meters, t is in seconds, and I cap and j cap denote unit vectors along x and y directions respectively. Which one of the following statements is wrong for the motion of particle? The first statement says magnitude of the velocity of particle is 8 meter per second. Second statement says path of the particle is circle of radius 4 meter. Third statement says acceleration vector is along minus r. And the last one is magnitude of acceleration vector is v square by r, where v is the velocity of the particle. So let's see, it is given that vector r equals to 4 sine 2 pi t I cap plus I cap will be outside the bracket, right? So 2 pi t I cap plus 4 cos 2 pi t j cap. Okay. So if we say that x is equal to 4 sine 2 pi t and y is equal to 4 cos 2 pi t, right? Because I cap and j cap denote the unit vectors along x and y direction. So x is equal to 4 sine 2 pi t and y is equal to 4 cos 2 pi t. If we say this is equation number 1 and this is equation number 2. So what will be 1 square plus 2 square? Okay. That means we'll find the square of these two and then add them up. That means we have to find out the value of x square plus y square. So this is helpful in making this solution easier. Let's see how. If you find the square of these, so square of x will be equal to, okay, it will be 4 square and then sine square 2 pi t. So, and here in y it will be 4 square cos square 2 pi t. So 4 square can be taken common and here we can say sine square 2 pi t plus cos square 2 pi t. And why we did so? Because now we have got it in the form of sine square a plus cos square a, okay, or sine square theta plus cos square theta, that is equal to 1. We know that sine square theta plus cos square theta is equal to 1. So this term becomes equal to 1. So we can say that x square plus y square is equal to 4 square. And we know that this is the equation of a circle. And this equation implies that the circle has the radius 4, with circle with radius 4, okay, 4 unit. It can be any unit which is mentioned in the question, so it is meter, okay. So 4 meter is the radius of the circle. So that is one thing is clear, that option B is a correct statement, okay. Second statement is the correct statement, that path of the particle is the circle of radius 4 meter, but we have to find the incorrect statement or the wrong statement. So this is the correct one. Second one is correct. Also we know that for a circular motion the acceleration is equal to v square by r, where v is the velocity of the particle. So statement D is also correct. This is also correct. And you also know that if this is the circle, okay, this is the vector r, this is velocity vector v, this is vector r, so the acceleration will be towards minus r. So option C is also correct. This is also a correct statement. So it is quite clear that first statement will be incorrect, but still we'll check how. So it is given in the first statement that magnitude of the velocity of the particle is 8 meter per second. So this will be incorrect. Let's see what will be the magnitude of the velocity. So what will be the velocity along the x direction? It will be the differentiation along the x direction, okay. So we can say that drx by dt. So we have to differentiate what? We have to differentiate this first term x, 4 sine 2 pi t. So we have to find the differentiation. So that means we'll get 4 into 2 pi, and the differentiation of sine theta is equal to cos theta. So we'll get cos 2 pi t, 2 pi t. Okay, so that is equal to 8 pi cos 2 pi t. Similarly, the velocity along the y direction. Velocity along the y direction will be dry upon dt. So let's differentiate 4 cos 2 pi t. So again we'll get 4 into 2 pi, and the differentiation of cos theta is minus sine theta. So we'll get minus sine 2 pi t. So here we'll get minus 8 pi sine 2 pi t. So these are the velocities along x and y direction. So what will be the net velocity? It will be equal to under root vx square plus vy square. Now if you solve it, on solving by putting the values of vx and vy, we'll get 8 pi meter per second. So the velocity is 8 pi meter per second, not 8 meter per second, okay, because pi is equal to 3.14. So in order to find the exact velocity, you have to multiply 8 by 3.14, and then the velocity that comes will be the velocity. Okay, so option A is incorrect. Magnitude of the velocity of the particle is not 8 meter per second, it is 8 pi meter per second. Okay, so the correct answer will be option number A. Now question number 4 is related to laws of motion, and the question says two stones of masses m and 2m are whirled in horizontal circles, the heavier one in a radius r by 2 and the lighter one in the radius r. The tangential speed of lighter stone is n times that of the value of the heavier stone when they experience same centripetal force. The value of n is, okay. So we have two stones, lighter stone and heavier stone, okay. They have masses m and 2m. So which one will have the mass m? Lighter one, okay, less mass, and 2m will be the mass of the heavier one. Then let's say the velocity or the tangential speed of the lighter one is v1 and that of the heavier one is v2. So it is given that when they experience same centripetal force, v1 will be n times v2. Okay, v1 is equal to n times v2. If we talk about the radii, so radius of the heavier one is given as r by 2 and the radius of the lighter one is r. So let's check. We know that they experience same centripetal force, so Fc1 equals to Fc2 and the centripetal force is equal to mv square by r. So let's put the values. For the first one, that means the lighter one, it will be equal to m into v1 square upon r. For the heavier one, it will be 2m into v2 square by r by 2. So r and 2 will go on the numerator side, right? So m will be cancelled, r will be cancelled. What will be left? v1 square equals to 4v2 square. Okay. So from here we can say that v1 is equal to 2v2. Okay. So it was given that v1 is equal to nv2 and here we have got v1 equals to 2v2. That means n is equal to 2. So option C will be the correct answer. Question number 5 is from the chapter Friction and the question is a plank with a box on it at one end is gradually raised about the other end. As the angle of inclination with the horizontal reaches 30 degree, the box starts to slip and slides 4 meter down the plank in 4 seconds. The coefficient of static and kinetic friction between the box and the plank will be respectively. Okay, so first we have to find out the coefficient of static friction and then we have to find out the coefficient of kinetic friction. So here it is given that as the angle of inclination with the horizontal reaches 30 degree, then the box starts to slip. So before this, the box does not slip. Okay. So this is the angle of repose. Here the theta, that is 30 degree, is the angle of repose. Angle of repose is that angle at which a body is just at the point of sliding. Okay. So here it is 30 degree. We know that the coefficient of static friction mu s is equal to tan theta. That means tan 30 degree, which is equal to 1 by root 3 and 1 by root 3 is equal to 0.6. So the coefficient of static friction will be 0.6. So here in the answers, the first one will be the coefficient of static friction. So in option number C and D only it is given 0.6. In A and B it is not 0.6. So A and B cannot be the correct answer. Okay, the answer will be between C and D. Now we have to check kinetic friction, but you can apply the common sense that kinetic friction is always less than the static friction. Okay, it is not equal to the static friction. So option number C is also incorrect because here static and kinetic friction both have same coefficient, so which is not possible. So option number D can be the correct answer because here the kinetic friction is less than static friction, but still we'll find out what is the value of kinetic friction. Let's see how. So we know that in this kind of situation where the box or any body is sliding like this, in this case the acceleration is constant. Okay, and that is given by the expression or the equation A equals to G sine theta minus mu k cos theta, where mu k is the coefficient of kinetic friction. This we have to find out, right? So since the acceleration will be constant in this situation, so we can apply the equation of motion S equals to ut plus half at square. Okay, so S means displacement and it is given in the question that the box moves 4 meter. Okay, it slides 4 meter, so the displacement is 4 meter. Ut will be 0 because the box had started from rest, so this will be 0. Then half at square, so half into a into t square. T, that means time, is given as, what is the time here? The time is given as 4 seconds. Okay, so 4 square, that means 16. So if we solve it, we'll get 8a. So from here the acceleration a will be equal to 4 by 8, that means 1 by 2 or 0.5. Okay, so acceleration is 0.5. Now if we put this value of acceleration in this equation, we can get the value of coefficient of kinetic friction. Okay, so like acceleration equals to G sine 30 degree minus mu k cos 30 degree. Okay, and in this A you have to put 0.5. So you will get the value mu k equals to 0.5. Okay, you can just solve and check. So option D will be the correct answer. Now question number 6. Two particles A and B move with constant velocities vector v1 and vector v2. At the initial moment their position vectors are vector r1 and vector r2 respectively. The condition for particles A and B for their collision is. Okay, so two particles are there and they are moving. The initial position vectors for A and B are vector r1 and vector r2 respectively, and the initial velocities for them are vector v1 and vector v2 respectively. Okay, so it is asked that what will be the condition under which these two will collide. Okay, collision will take place. So these two particles are moving. The initial position vector for A is vector r1 and for B it is vector r2. This is the initial position vector. Okay, the velocities are v1 and v2. So what will be the displacement after time t? Displacement after time t. For A it will be v1 into t. Okay, velocity into time is the displacement, and for B it will be v2 into t. Okay, so the final position will be equal to initial position vector plus displacement. Okay, so for A it will be vector r1 plus v1 into t, and for B it will be vector r2 plus vector v2 into t. Okay, so these are the final positions, and we know that for collision, when will collision take place? When their final position will be same, right? Because if two particles collide, their final position will be same. So for collision, vector r1 plus v1 t will be equal to vector r2 plus v2 t. Okay, that means the final position should be same. Now let's arrange it. So vector r1 minus vector r2 will be equal to vector v2 minus vector v1 into t. Okay, we can write it like this. Now what will be the magnitude of t? T is a scalar quantity. Okay, so it doesn't have a direction. It only has magnitude. So the magnitude of t will be magnitude of displacement divided by magnitude of velocity. So magnitude of displacement will be vector r1 minus vector r2, magnitude of this, upon the magnitude of velocity, so v2 minus v1. Okay, so let's put this value in t. On the left hand side we have vector r1 minus vector r2, and this side we have vector v2 minus vector v1, and then in place of t we can write r1 minus r2 upon v2 minus v1. Okay, magnitudes of these. Now if we rearrange it, we'll get the answer. If we bring this side, okay, vector r1 minus vector r2 on the left hand side, then we'll get vector r1 minus vector r2 upon magnitude of vector r1 minus vector r2, and this side we get vector v2 minus vector v1 upon magnitude of v2 minus v1. Okay, so this is the condition for collision to take place, and this is given in option number C, third option, right? So option C will be the correct answer. Now question number 7 is from work, energy and power, and the question is, the heart of a man pumps 5 liters of blood through the arteries per minute at a pressure of 150 millimeter of mercury. If the density of the mercury be 13.6 into 10 to the power 3 kg per meter cube and G is equal to 10 meter per second square, then the power in watt is. So we have to find the power in watt. Power is equal to work done per unit time, and work done is pressure into volume. So pressure into volume per unit time. So let's find the values of pressure, volume and time first. We know that this question says that the pressure of the blood is 150 millimeter of mercury. Okay, so it is given in terms of mercury. So that means if this is the tube, the mercury rises at 150 millimeter. Okay, at this height. In terms of meter, it will be 0.15 meter. Okay, so height will be 0.15 meter and density of the mercury is given as 13.6 into 10 to the power 3 kg per meter cube, and g, that means acceleration due to gravity, is given as 10 meter per second square. Okay, so what will be the pressure? Pressure will be equal to rho into g into h, that means 13.6 into 10 to the power 3 into g, that means 10, into h, that means 0.15. Okay, so this will be the pressure of the blood as well, because here it is compared to the mercury. So on solving this, what do we get? We'll get to 20.4 into 10 to the power 3 Newton per meter square. This will be the pressure. So let's put this value here. In place of pressure, we can write 20.4 into 10 to the power 3 Newton per meter square. Then volume. So volume is given 5 liters, right? Volume is 5 liters. In terms of meter cube, it will be 5 into 10 to the power minus 3 meter cube. So in place of volume, we can write 5 into 10 to the power minus 3 meter cube. Okay. And then time. Time is also given in the question per minute. Okay. 5 liters of blood through the arteries per minute. That means in 60 seconds. SI unit for time will be second. So we are finding it 60 seconds. Now we just have to solve it. On solving this, you'll get approximately 1.7 watt. Okay, so option number C, 1.70 watts, will be the correct answer. Next question is from work, energy and power, and the question is, a ball is thrown vertically downwards from a height of 20 meter with an initial velocity v0. It collides with the ground, loses 50% of its energy in collision and rebounds to the same height. The initial velocity v0 is. So we have this ball which is at the height of 20 meters from the ground. It is moving with the initial velocity of v0. It collides the ground, loses 50% of its energy, and then it rebounds to the same height and then finally stops here. Okay, because if it would not stop here, then it would not be its final height. It would further move upward, right? But this is its final height. That means here it stops. So the final speed is, or the final velocity is 0. Okay, so initially the total energy of the ball was the sum of kinetic energy and potential energy, because it had an initial velocity. So kinetic energy was also there. That means the total energy was half mv0 square plus mgh. But finally, at the final point, the total energy will only be the potential energy. That means mgh, because it does not have any velocity here. Okay, final velocity is 0, so there is no kinetic energy. But it is given that when it collides the ground, it loses 50% of its energy. That means the final total energy is half of the initial energy, because half energy has been lost. So the final total energy is half of the total initial total energy. Okay, half of initial total energy. So we can say that mgh is equal to half of half mv0 square plus mgh. Okay, so 2 mgh is equal to half mv0 square plus mgh. Okay, if we take this mgh this side, then 2 mgh minus mgh means mgh. Okay, so mgh will be equal to half mv0 square. M is on both the sides, so it can be cancelled. So 2gh equals to v0 square. That means v0 equals to under root 2gh. Now we simply have to put the values under root 2 into g, that means 10 meter per second square, and height is 20 meters. Okay, it is given in the question. Under root 400, that means 20, and the unit for velocity is meter per second. So 20 meter per second, that means option D is the correct answer. Okay. Next question is, on a frictionless surface, a block of mass m moving at a speed v collides elastically with another block of same mass m, which is initially at rest. After collision, the first block moves at an angle theta to its initial direction and has a speed v by 3. The second block's speed after collision is. Okay, so we have a block of mass m it is moving with the speed v, then it collides elastically with another block of same mass that is at rest. Okay, so this second mass has speed 0. When it collides elastically, then the first mass or the first block moves at an angle theta to its initial direction. This is the angle theta. This is the first mass. Okay, and now its speed is v by 3. Similarly, second block also moved, but we don't know what is the speed of this second block. Let's say it is v dash. So we have to find the speed of the second block. That means we have to find the value of v dash. Okay. Now we know that in case of elastic collision, initial kinetic energy is equal to the final kinetic energy, isn't it? So what is the initial kinetic energy of the first block? Half mv square. And the second block 0 because it was at rest. Final kinetic energy of the first block is half m v by 3 square. And for the second block it is half m v dash square. Okay. We have to find the value of v dash. So first let's solve it. From here only we'll get the value of v dash. Half mv square this side and this side we get mv square upon 18. Okay, because square of 3 is 9 and 9 into 2 18 plus half m v dash square. Now m can be eliminated from here. So half v square on the left hand side, and on the right hand side if we take the LCM 18, here we get v square plus here we get 9v dash square. Okay, so 2 into 9 is 18, so 9v square. Okay, we bring this 9 this side, so 9v square equals to v square plus 9v dash square. On further solving it, we get 9v square minus v square, that means 8v square equals to 9v dash square. So simply v dash square equals to 8 by 9v square, and v dash is equal to under root 8 by 9 v square. So on solving this, what do we get? V is equal to, it will be 2 root 2 by 3v. Okay, thus under root of this is 2 root 2 by 3v. So the v dash, that means the speed of the second block after elastic collision, will be 2 root 2 by 3v. That means option C will be the correct answer. Now question number 10 is from rotational motion, and the question is, point masses m1 and m2 are placed at opposite ends of a rigid rod of length L and negligible mass. The rod is to be set rotating about an axis perpendicular to it. The position of point P on this rod through which the axis should pass, so that the work required to set the rod rotating with angular velocity omega naught is minimum, is given by. Okay. So we have these two masses m1 and m2. Okay, these are point masses. Let's assume that point m1 is at the origin. So its position will be 0, 0. And m2 is at a distance L from m1. So its position will be L, 0. Okay, y-axis is 0. And x is 0 for m1 and L for m2. Okay, because the length of this rod is L. Now you can see this, that the axis is passing through a point P which is at a distance x from m1 and at a distance L minus x from m2. So first of all, it is given that the work required to set the rod rotating should be minimum. Okay, we know that the work done is equal to change in kinetic energy, and that will be equal to half I omega naught square. So here, since the work done has to be minimum, we know that the work done will be minimum when the moment of inertia will be minimum. Okay, and the moment of inertia is minimum when the axis passes through the center of mass. So work done is minimum here. That means the axis is passing through the center of mass, is passing through center of mass of the rod. Then only the moment of inertia will be minimum. Okay. So this P is the center of mass. Point P is the center of mass of the rod. So we have to find the position of this P. That means we have to find this distance x. Okay. So xcm will be equal to m1x1 plus m2x2 upon m1 plus m2. Simple formula. Let's put the values. M1 and x1 is 0. Okay. Because m1 is at the origin. So x1 is 0. So this m1 x1 will be equal to 0. Plus x2, that means the position of m2 along the x-axis is L. Okay. So it is m2 into L upon m1 plus m2. Okay. So we can say that x is equal to m2L upon m1 plus m2. So which answer is the correct one? Option number B seems to be correct, right? Option number B is the correct answer. Question number 11 is again from rotational motion, and the question is, an automobile moves on a road with a speed of 54 km per hour. The radius of its wheel is 0.45 meter and the moment of inertia of the wheel about its axis of rotation is 3 kg meter square. If the vehicle is brought to rest in 15 seconds, then the magnitude of average torque transmitted by its brake to the wheel is. So we have to find the magnitude of average torque. We know that the torque is equal to I into alpha. I is the moment of inertia, alpha is the angular acceleration, and alpha is equal to A by R. Okay, I into A by R. Okay, A is the linear acceleration and A is also equal to velocity by time. So it can be written as I into V by T into R. This will be the average torque, magnitude of average torque. Okay, now let's see. What is the moment of inertia? It is given in the question 3 kg meter square. Okay. So I is equal to 3 into what is the speed? It is 54 kilometers per hour. So we will convert it into meter per second. Okay. So V is equal to 54 kilometers per hour. That means 54 into 1000 upon 3600 meters per second. Right. So on solving this, you'll get 15 meter per second. Okay. So V is 15 meter per second upon T. That means time. It is given as 15 seconds. 15 into R. That means radius of the wheel is 0.45 meter. So 0.45 meter. Now let's solve it. 15 will be cancelled. Here we get 300 by 45. Okay. This decimal will be removed. So 300 by 45. On solving this, you'll get 100 by 15. That means 6.66 and the unit will be kg meter square per second square. So option C will be the correct answer. Alright, next question is a force vector F equals to alpha I cap plus 3j cap plus 6k cap is acting at a point vector R equals to 2I cap minus 6j cap minus 12k cap. The value of alpha for which angular momentum about its origin is conserved is. Okay. So we know that the torque is equal to dl upon dt. Okay, where L is the angular momentum. Angular momentum. Now it is given in the question that the angular momentum about the origin is conserved. It means torque will be 0. Okay, when angular momentum is conserved, it means torque is equal to 0. And we know that torque is equal to vector R cross vector F. So vector R cross vector F should be equal to 0. So let's find out the value of vector R cross vector F first. Vector R cross vector F. That means position vector cross force. So how do we find the cross product? Here we write I cap, then j cap, then k cap. For the position vector, the x component is 2. Okay, 2I cap. So 2, then minus 6j cap. So minus 6 here and minus 12k cap. So minus 12 here. Okay. Similarly for force, it is alpha I cap. So the x component is alpha. Then 3j cap. So 3 here and 6k cap. So 6 here. Okay. Now how do we find the cross product? First, for the the x component, we write I cap and then we hide the I column. Okay. Just hide the I column and cross multiply j and k column. So minus 6 into 6, that means minus 36, minus 3 into minus 12, that means minus 36. Okay, minus j cap. For j cap, we have to hide the j column and cross multiply I and k column. Okay, so 2 into 6 is 12, minus alpha into minus 12, that means minus 12 alpha. Okay, now we have k cap. For k cap, we have to hide the k column and cross multiply I and j. So for this, 2 into 3, that means 6, minus alpha into minus 6, that means minus 6 alpha. Minus 6 alpha. So it can be written as 0 I cap minus 12 plus 12 alpha j cap plus 6 plus 6 alpha k cap. Okay. Now we have seen that here the angular momentum about the origin is conserved. That means the torque, vector torque should be equal to 0. So this cross product should be equal to 0. Okay. That means it should be equal to 0 I cap plus 0 j cap plus 0 k cap. Okay. On the left side and right side, I cap are 0. Okay. So we cannot compare these. But j cap we can compare and then find the value of alpha. Okay. So if we compare the j cap, on the left hand side we have 12 plus 12 plus 12 alpha, and on the right hand side we have 0. So from here we can say that alpha is equal to minus 12 by 12, that means minus 1. Okay. Similarly, you can find out using the k1 or k cap also. Okay, 6 plus 6 alpha this side and this side it is 0. So alpha should be equal to minus 1. Okay. So in any case, alpha is coming out to be minus 1. So option C minus 1 will be the correct answer. Now question number 13 is from gravitation, and the question is, a remote sensing satellite of Earth revolves in a circular orbit at a height of 0.25 into 10 to the power 6 meter above the surface of Earth. If Earth's radius is 6.38 into 10 to the power 6 meter and g is equal to 9.8 meter per second square, then the orbital speed of the satellite is. Okay. So we have to find the orbital speed of the satellite, that means V naught. We have a direct formula for this, under root gm upon r plus h. H is the height. Okay. So that is given as 0.25 into 10 to the power 6 meter. And we know that small g, that means acceleration due to gravity, is equal to capital G into m upon r square. So in place of gm, we can write small g into r square. Okay. So let's put this in this formula. We have small g into r square upon r plus h. Now here we have r square, so we can take r outside the root. So it will be r and then under root g upon r plus h. Now we simply have to put the values. R, that means radius, is 6.38 into 10 to the power 6 meter. Then we have under root g, acceleration due to gravity, 9.8 upon r plus h. That means 6.38 into 10 to the power 6 plus h, that means 0.25 into 10 to the power 6. Now this calculation is going to be quite lengthy, but you have to do this, and when you solve it, you will get approximately 7.76 into 10 to the power 3 meter per second. So here in the options you have kilometer per second. So in place of 7.76 into 10 to the power 3, you can simply write 7.76 kilometer per second. So this way option C will be the correct answer. Question number 14 is again from gravitation, and the question is, a satellite S is moving in an elliptical orbit around the Earth. The mass of the satellite is very small compared to the mass of the Earth. Then the first statement says the linear momentum of S remains constant in magnitude. So this is incorrect because the linear momentum will change due to the change in the velocity. Okay. Then the second statement says the acceleration of S is always directed towards the center of the Earth. Yes, this is correct because the gravitational force on the satellite due to the Earth always acts towards the center of the Earth. Therefore, the acceleration will always be directed towards the center of the Earth. Okay. Then the third statement says the angular momentum of S about the center of the Earth changes in direction, but its magnitude remains constant. So this is incorrect. The angular momentum will be constant in magnitude as well as direction. Okay. So both will be constant. The direction will not change. It will also remain constant because there is no external torque. No external torque. So in the absence of any external torque, the angular momentum will remain constant in magnitude as well as direction. Okay. So in the first statement, we have seen linear momentum will change, but angular momentum will remain constant. Then the last statement says the total mechanical energy of S varies periodically with time. So again, there is no external force, no external force. So due to the conservation of energy, according to the conservation of energy, the total energy, mechanical energy of the satellite will remain constant. Okay, it will not vary periodically with time. It will remain constant. So out of the four statements, only the second statement is correct. So option B will be the correct answer. Question number 15 is from mechanical properties of fluid, and the question is water rises to a height h in capillary tube. If the length of the capillary tube above the surface of water is made less than h, then. So we have this capillary tube here that is kept above the surface of the water. This is water here. Then water rises up to height h in the capillary tube. Okay. Now it says that if the length of this capillary tube that is kept above the surface of the water is made less than h, then what will happen? So we know that height h is equal to 2t upon rho g r. Okay. So we can say that h into r is equal to 2t by rho into g, which is constant for a given liquid. Okay. This is constant for a given liquid. So h into r is constant. That means this height h will be inversely proportional to the radius of curvature. So when height is reduced, when this height of the capillary tube is reduced, then the radius of curvature of the liquid inside this capillary tube will increase. Okay. So if this is your initial radius, it will become like this. Okay. Or like this. So there will be only change in the radius of the curvature and it will rise up to the top of the capillary tube. Okay. But it will not overflow. So option D will be the correct answer. Water rises up to the top of the capillary tube and stays there without overflowing, and its radius of curvature will also change. Okay. Alright, next question says the value of coefficient of volume expansion of glycerine is 5 into 10 to the power minus 4 per Kelvin. The fractional change in the density of glycerine for a rise of 40 degrees Celsius in its temperature is. So the coefficient of volume expansion, that means gamma, is given as 5 into 10 to the power minus 4 per Kelvin, and the change in temperature delta T is given as 40 degrees Celsius. We have to find the fractional change in the density of the glycerine. That means we have to find the change in density delta rho upon the initial density, that means rho naught. Okay. So this we have to find out. So for that we should know the formula. Rho equals to rho naught 1 minus gamma delta T. Okay, this is the formula. So rho upon rho naught will be equal to 1 minus gamma delta T. So we can say that gamma delta T equals to 1 minus rho upon rho naught. And on solving this one, we'll get rho naught on the denominator side and here rho naught minus rho. So this is the same thing, delta rho upon rho naught, right? This is the fractional change in the density. So we can see that this is equal to gamma into delta T. So this fractional change, that means rho naught minus rho upon the initial density, that means rho naught, is equal to gamma into delta T. So we simply have to put the values. Gamma is given as 5 into 10 to the power minus 4 per Kelvin and delta T is given as 40 degree Celsius. So on solving this, you'll get 200 into 10 to the power minus 4, that means 0.02. So option D will be the correct answer. Now question number 17. The cylindrical tube of a spray pump has radius capital R, one end of which has n fine holes, each of radius small r. If the speed of the liquid in the tube is V, then the speed of ejection of the liquid through the holes is. Okay. So we have this kind of cylindrical tube. Okay. This is the first end and this is the second end. Now in the second end, there are n number of small holes. Okay, there are n number of small holes, each of radius small r. Okay, total n holes are there. The speed of the liquid is v. Okay, we have to find the speed of the ejection of the liquid through these holes. Okay, through these holes. So there are n number of holes, so liquid will be ejecting out from all these n number of holes. Okay, so for that we should know that the product of area into and velocity is constant. Okay, area into velocity is constant, so a1 v1 will be equal to a2 v2. Okay, area of the first one will be pi r square, pi capital R square. Okay, because this has the radius capital R, and the velocity or the speed of the liquid is v. It is given in the question. This side, that means on the side where there are n number of holes, area of each hole will be pi into small r square, and there are n number of holes, so this will be multiplied by n into v2. So v2 we have to find out. Okay, so here we can see that pi can be cancelled. We have to find out the v2, so that will be equal to r square into v upon small r square into n, right? Or if we rearrange them, we can write it like this: v r square upon n small r square. Okay, so v into capital R square upon n into small r square. Let's see which option is the correct one. Option number D will be the correct answer. Question number 18 is from thermal properties of matter, and the question is: the Young's modulus of steel is twice that of brass. Two wires of same length and of same area of cross section, one of steel and another of brass, are suspended from the same roof. If we want the lower ends of the wires to be at the same level, then the weights added to the steel and brass wires must be in the ratio of. So we have two wires. This is the steel wire. This is the wire made up of steel, and the other wire is brass wire. Okay, these have same length, so L1 is equal to L2, and same area of cross section, A1 is equal to A2. Now we have to add some weight to both the wires. Okay, suppose these are the weights W1 and W2 added to the steel and brass wire respectively. So when we add a weight, there definitely there will be some increase in the length of the wire, but we want the lower ends of the wire to be at the same level. So we have to add the weight such that the length of the final length of the wire remains same. Okay, the lower length remains at the same level. So for that we should remember the formula: Young's modulus is equal to force F into L, length of the wire, upon A, that means area of cross section, into delta L. Okay, so here lengths are same and area of cross section are also same. So L, delta L and A will be same. So Young's modulus will be directly proportional to the force, and force is directly proportional to the weight. Okay, mass into acceleration. That means Young's modulus is directly proportional to the weight. So Young's modulus of the steel upon Young's modulus of the brass will be equal to W1 by W2. And this is the ratio that we have to find out, W1 by W2. Okay, and it is given that the Young's modulus of the steel is twice that of brass. So this Young's modulus is 2 times that of the Young's modulus of the brass. So 2 times the Young's modulus of the brass, and here we have Young's modulus of the brass. That means this ratio is 2 by 1. Okay, W1 by W2 is equal to 2 is to 1. Got it? So option D will be the correct answer. Question number 19 is from thermodynamics, and the question is: an ideal gas is compressed to half its initial volume by means of several processes. Which of the process results in the maximum work done on the gas? So here you can see that if it is compressed to half its initial volume, volume is compressed, right? Volume is changed, right? It decreases by half. So isochoric is not possible because in case of isochoric, volume remains constant. But in this case, volume is not constant. It is reduced to half. For others, let's check. First, we'll draw the PV graph, pressure versus volume graph. So if this is your initial volume V0, then the final volume will be V0 by 2. Right? This is V0 initial volume and this is V0 by 2 final volume. Now let's see the graph. For isothermal, it will be like this. For adiabatic, it will be like this. That means above the isothermal. And then for isobaric means same pressure. Same pressure. So here pressure will not change. It will be a straight line like this. So this one is isobaric. Above this is isothermal. And the uppermost one is adiabatic. We have to find out which process will result in the maximum work done. So we know that the work done is equal to the area under the PV graph. Area under PV graph. So which one will give the maximum area? This adiabatic process will give the maximum area. Others area will be less than this one. Okay. So it is maximum in case of adiabatic. And it is minimum in case of isobaric. So option C will be the correct answer. Adiabatic process will result in the maximum work done on the gas. Next question is again from thermodynamics and the question is the coefficient of performance of a refrigerator is 5 if the temperature inside the freezer is minus 20 degrees Celsius. The temperature of the surrounding to which it rejects heat is. Okay. So we know that temperature of the surrounding is taken as T1 and temperature inside the freezer is taken as T2. Okay. And we know that the coefficient of performance beta is equal to T2 upon T1 minus T2. Okay. So let's put the values. Beta is given as 5. Coefficient of performance of the refrigerator is 5. T2, that means temperature inside the freezer is given minus 20 degrees Celsius. So we'll use the unit Kelvin here. So minus 20 plus 273, that means 253 Kelvin. So T2 is 253 Kelvin. T1 is unknown. We have to find out minus T2, that means minus 253. Now let's solve it. If we take this side, T1 minus 253 will get 5 T1 minus 5 into 253. That means it will be 1265. 1265 equals to 253. So 5 T1 equals to 253 plus 1265. So it will be 1518. Okay. And from here we can say that T1 is equal to 1518 divided by 5. That is equal to 303.6 Kelvin. But the options are in centigrade. So let's convert it. 303.6 Kelvin minus 273 is equal to 30.6 degrees Celsius. That means approximately equal to 31 degrees Celsius. So option C will be the correct answer. Next question is from kinetic theory of gases and the question is two vessels separately contain two ideal gases A and B at the same temperature, the pressure of A being twice that of B. Under such conditions, the density of A is found to be 1.5 times the density of B. The ratio of molecular weights of A and B is. Okay. So we have two vessels. This is vessel, first vessel, this is the second vessel. They contain two ideal gases A and B. A and B which are at same temperature. So TA is equal to TB. The pressure of A is twice that of B. So pressure of A is 2 times the pressure of B. And then the density of A is 1.5 times the density of B. So rho of A is 1.5 means 3 by 2 times rho of B. So these are mentioned in the question. We have to find the ratio of molecular weights of A and B. Okay. So we know that according to the ideal gas equation, PV equals to nRT. PV equals to nRT. Number of moles N is equal to PV upon RT. Okay. And we also know that number of moles is equal to given mass by molar mass or molecular mass. Molecular mass. Here we are using molecular mass because we have to find the ratio of molecular mass or molecular weight. Okay. So using this, what will be the value of molecular mass? Molecular mass will be equal to given mass by PV into RT. Okay, and mass by volume is equal to density. So it can be written as rho, that means density, into RT upon P, that means pressure. So molecular mass will be equal to rho RT upon P. Now we have to find the ratio of the molecular masses of A and B. So molecular mass of A by molecular mass of B will be equal to density of A by density of B into R is a constant, so we can just skip it because R will be same. Then T, temperature of A by temperature of B, and pressure is inverse here, okay, on the denominator side. So we can write it as PB by PA. Now let's put the values. We have seen that rho A is equal to 3 by 2 times rho B. So this rho A by rho B will be equal to 3 by 2. This ratio will be equal to 3 by 2. And temperatures are equal. So TA and TB are equal. They can be cancelled. And PB by PA. So we know that PA is equal to 2 times PB. So this ratio will be equal to 1 by 2. So 3 by 4 will be the ratio of the molecular weights of A and B. 3 is to 4 or 3 by 4. Option D will be the correct answer. Question number 22 is from simple harmonic motion, and the question is, a particle is executing a simple harmonic motion. Its maximum acceleration is alpha and maximum velocity is beta. Then its time period of vibration will be. So we know that maximum acceleration is equal to a omega square. So according to this question, alpha is equal to a omega square. And we know that maximum velocity is equal to a into omega. So according to this question, beta is equal to a into omega. Okay. Now in this equation, alpha equals to a omega square, we can write it like this, a omega into omega, and a omega is equal to beta. So alpha is equal to beta into omega. So from here we can say that omega is equal to alpha by beta. Okay. So omega is the ratio of alpha and beta. Now we have to find the time period of vibration. So it's very simple. We know the time period is equal to 2 pi by omega. So we'll just put this value here, 2 pi by omega. Omega is equal to alpha by beta. So alpha and beta here. So it will be equal to 2 pi beta upon alpha. It will be the time period of the vibration. Option B will be the correct answer. Now, the question says 4 grams of a gas occupies 22.4 liters at NTP. The specific heat capacity of the gas at constant volume is 5 joule per Kelvin per mole. If the speed of sound in this gas at NTP is 952 meter per second, then the heat capacity at constant pressure is. So, what are the things given in the question? It is given that the specific heat capacity of the gas at constant volume is 5 joule per Kelvin per mole. That means CV. The specific heat capacity at constant volume is CV. That is given as 5 joule per Kelvin per mole. Then speed of the sound V is given as 952 meter per second. And we have to find out the heat capacity at constant pressure. That means we have to find the value of Cp. Okay. So we know that gamma is equal to Cp by Cv. So from here we can find out the value of Cp, that will be equal to gamma into Cv. So Cv is already given here. We have to find the value of gamma, then we can multiply them to find out the value of Cp. Okay. So for that we'll use the formula. The speed of the sound in this gas at STP is equal to under root gamma into RT upon M. Okay. Gamma RT by M. Under root gamma RT by M is the formula for speed of the gas. Okay. So from here we can say that gamma will be equal to V square M upon RT. So let's put the values. V is given as 952 meter per second. So 952 into 952. Then M is given as 4 grams. Okay. 4 grams of the gas. So 4 grams, that means 4 into 10 to the power minus 3 kg upon RT. R is the gas constant, that is equal to 8.3. and temperature will be 273. Now if you solve it, you'll get 1.6. So this will be the value of gamma. Now Cp, that means the heat capacity at constant pressure, will be equal to gamma into Cv. That means 1.6 into Cv is 5. So 5, answer will be 8 and the unit will be joule per Kelvin per mole. So 8 joule per Kelvin per mole, option C will be the correct answer. Now next question is from sound, and the question is, a source of sound S emitting waves of frequency 100 Hz and an observer O are located at some distance from each other. The source is moving with a speed of 19.4 meter per second at an angle of 60 degree with the source observer line as shown in the figure. The observer is at rest. The apparent frequency observed by the observer is, velocity of the sound in air is 330 meter per second. So you can see this is the source S, this is the observer O in the figure. Okay, this source is moving at a speed of 19.4 meter per second, making an angle 60 degree with this source observer line. So what will be the effective speed of the source? The effective speed of the source will be 19.4 cos 60 degree. Okay, along this line. So 19.4 cos 60 degree is half. So we'll get 9.7 meter per second. This is the speed of the source. And what about the speed of the observer? It is 0 because the observer is at rest. So we have to find the apparent frequency observed by the observer. So we know the formula F dash, apparent frequency, is equal to V plus V naught upon V minus Vs into frequency F. Okay, V is the speed of the sound in air. So that is given as 330 meter per second. So 330, and VO, that means speed of the observer, is 0. So we can just skip that, upon V minus Vs. So 330 minus Vs is 9.7. So 9.7 and multiplied by the frequency that is given here. So frequency was 100 Hertz, right? Into 100. If you solve it, you'll get 103 Hertz. This will be the apparent frequency that will be observed by the observer. So option D will be the correct answer. Next question 25 is again from waves, and the question is, a string is stretched between fixed points separated by 75 centimeter. It is observed to have resonant frequencies of 420 Hz and 315 Hz. There are no other frequencies between these two. The lowest resonant frequencies for this string is, so this is very simple. It is given that the resonant frequencies of 420 Hz and 315 Hz are observed, and there are no other frequencies between them. That means these are two consecutive frequencies. Okay, so difference between them will be 420 minus 315 Hz, that is equal to 105 Hz. This is the difference between them. Okay, and we know that in a stretched string, let's write it down here, in a stretched string, if the fundamental frequency is n, if the fundamental frequency is n, then the higher frequencies will be 2n, then 3n, 4n, and so on. That means the difference between any two successive frequencies will be n. So difference between two successive frequencies is equal to n. It is clear here, from here. Okay, 2n, 3n, 4n. So the difference is equal to n. And here we have seen that the difference of two successive frequencies is equal to 105 Hz. That means n is equal to 105 Hz. And we know that n is the fundamental frequency or the lowest resonant frequency. Other frequencies will be higher than it only. That means 2n, 3n, 4n. So 105 Hz, option B will be the correct answer. Now question number 26. The fundamental frequency of a closed organ pipe of length 20 cm is equal to the second overtone of an organ pipe open at both the ends. The length of organ pipe open at both the ends is. So length of the closed organ pipe is given as 20 centimeter, and we have to find the length of the open organ pipe when the fundamental frequency of the closed organ pipe is equal to the second overtone of the open organ pipe. Okay, so for the closed organ pipe, we know that the fundamental frequency is equal to V by 4L. Okay, and this is the L of the length of the closed organ pipe, so LC. Okay, and for the open organ pipe, what is the fundamental frequency? This is equal to V by 2L. So V by 2L open, but the fundamental frequency of the closed one is equal to the second overtone of the open organ pipe. So the second overtone, that means the third harmonic, that means third harmonic of the open organ pipe is equal to 3 times V by 2L open. Okay, so this one, the first one is equal to the second one. Okay, V by 4LC is equal to 3 times V by 2L open. So let's equate them and then we can find out the length of the open organ pipe. So V by 4L closed is equal to 3 times V by 2L open. Okay, we can be cancelled from here. Then we can see that L open will be equal to 3 by 2 into 4 times L closed. So 2 into 2 is 4. So 3 into 2, 6 times L closed. So L of the open organ pipe is equal to 6 times the length of the closed organ pipe. That means 6 into, what was the length of the closed organ pipe? 20 centimeter, right? 20 centimeter. So 6 into 20, that means 120 centimeter is the length of the open organ pipe. 120 centimeter, option A will be the correct answer. Now question number 27 is from electrostatics, and the question is, a parallel plate air capacitor has capacity C, distance of separation between the plates is D, and the potential difference V is applied between the plates. Force of attraction between the plates of parallel plate air capacitor is. So we know that the force of attraction between the parallel plate capacitor is equal to Q square by 2A epsilon naught. Okay, and Q is equal to C into V. So in place of Q square, we can write C square V square upon 2A epsilon naught. Now in the options, we don't have A and epsilon naught. So for that, we can consider that C is equal to epsilon naught A by D. Okay, we know this formula. So epsilon naught into A will be equal to C into D. So in the place of A into epsilon naught, we can write C into D. Okay. So C square V square by 2 into C into D. So one C will be cancelled. So the answer will be CV square by 2D. This will be the force of attraction. So which option will be the correct one? CV square upon 2D. Option D will be the correct answer. Next question, if potential in volts in a region is expressed as Vxyz equals to 6xy minus y plus 2yz, then the electric field at point 110 is. So the potential difference is given as 6xy minus y plus 2yz. So what will be the electric field? We know that the electric field will be equal to minus del V by del x I cap plus del V by del y j cap and plus del V by del z k cap. Okay, so we have to do partial differentiation of the potential. So let's see, minus and del V by del x will be equal to 6y I cap plus del V by del y will be equal to 6x minus 1 plus 2z j cap plus del V by del z will be equal to 2y and then k cap. Okay. So this is the electric field. Now we have to find the electric field at point 110. That means we have to put x equals to 1, y equals to 1 and z equals to 0. So if we put these values, we'll get 6 into 1, that means 6 I cap plus 6 into 1 minus 1 and then 2 into z is 0. Okay, so this is 0. So 6 minus 1, that means 5. So 5 j cap plus 2 into 1, that means 2 k cap. So this is the electric field at the point 110. minus 6i cap plus 5j cap plus 2k cap. Option D will be the correct answer. Next question is from current electricity, and the question is, two metal wires of identical dimensions are connected in series. If sigma 1 and sigma 2 are the conductivity of the metal wires respectively, then the effective conductivity of the combination is. Okay, so we have two metal wires. This is the first metal wire, this is the second metal wire. They have identical dimensions, that means L1 will be equal to L2. So let's say L is the length of each one of them. The metal conductivities are sigma 1 and sigma 2. So when they are connected in series, we have to find the effective conductivity of the combination. First of all, we know that resistance is equal to rho L by A, where rho is the resistivity, L is the length of the conductor, and A is the area of cross section. And we also know that rho is equal to 1 by sigma. So resistivity is the inverse of conductivity. So it is equal to L by sigma A, right? Now in series combination, the effective resistance is equal to the sum of the individual resistances, so R1 plus R2. Okay, what will be the effective resistance in terms of the conductivity? The total length, that means 2L, upon the effective conductivity of the combination, that means sigma, into the area of cross section, so that will remain same, A. And this side R1 plus R2. So for the first conductor, it will be L by sigma 1 into A, and for the second one, it will be L by sigma 2 into A. Now on solving this, we can find out the value of this sigma. Okay, so L can be cancelled and A can also be cancelled. So 2 by sigma is equal to 1 by sigma 1 plus 1 by sigma 2. On solving this 1 by sigma 1 plus 1 by sigma 2, we get sigma 1 sigma 2, and here sigma 1 plus sigma 2. Okay, so this is equal to 2 by sigma, but we have to find out the sigma. So that will be equal to 2 into sigma 1 sigma 2 upon sigma 1 plus sigma 2. So this is the effective conductivity of the combination. So 2 sigma 1 sigma 2 by sigma 1 plus sigma 2, option C will be the correct answer, and you can directly remember this also. Okay. Now question number 30 says a circuit contains an ammeter, a battery of 30 volt and a resistance of 40.8 ohm, all connected in series. If the ammeter has a coil of resistance 480 ohm and a shunt of 20 ohm, then the reading in the ammeter will be. So let's draw the circuit diagram first. We have a resistance of 40.8 ohm. Then the battery is 30 volt battery. Now it is given that the ammeter has the coil of resistance 480 ohm. That means here the ammeter has a coil of resistance 480 ohm that has a shunt of 20 ohm. That means another resistance of 20 ohm in parallel to this. Then we have to find the reading of the ammeter. Okay. So this is how the current is flowing. Now for this part where the coil of resistance 480 ohm is connected in parallel with the resistance of 20 ohm, the effective resistance for this part will be effective. Let's say this is point A and this is point B. Then the resistance between AB will be equal to R1 R2 upon R1 plus R2, right? Because these are in parallel. So 480 into 20 ohm upon 480 plus 20, that means 500. So on solving this, we'll get 19.2 ohm. So this is for this part only, okay, A and B. And the total effective resistance will be equal to 40.8 plus this 19.2, because this AB, resistance between AB, is in series combination with this 40.8 ohm resistance. Okay, so the effective resistance of the circuit will be equal to 60 ohm. Okay, and we have to find out the current. So current will be equal to the potential difference or the voltage divided by the effective resistance. Voltage is 30 volt, effective resistance is 60. So it is 1 by 2 ampere, that means 0.5 ampere. So the ammeter will show the reading 0.5 ampere. That means option C will be the correct answer. Question number 31 says a potentiometer wire of length L and a resistance R are connected in series with a battery of EMF E0 and a resistance R1. An unknown EMF E is balanced at a length small l of the potentiometer wire. The EMF E will be given by. Okay. So first of all, we have a potentiometer wire. Let's say it is AB of length capital L. Okay. Its length is capital L and its resistance is small r. Okay. Now it is connected in series with an EMF E0. So this is E0 and a resistance R1. So this is R1. So this is how the current will flow. Okay. So first of all, what will be the current? Current will be equal to the EMF, that means E0, divided by the total resistance, that means R1 plus R. Okay. This is the current. And what will be the potential across AB or the voltage across AB? VAB will be equal to current into the resistance of this wire AB. That means small r. I into small r. And I is equal to E0 by R1 plus R. So let's put this value E0 by R1 plus R into R. Okay. So this is the voltage across or the potential across the wire AB. Okay. Now we have to find out the potential gradient, because for this type of question we solve the question by using the potential gradient. So potential gradient, that means K is equal to voltage divided by the length of the wire AB, that means capital L. Okay. So V is this one, E0 by R1 plus R into R. So E0 by R1 plus R into R divided by the length of the wire capital L. This is the potential gradient. Let's say this is equation number 1. Now what happens? An unknown EMF E is balanced at a length L of the potentiometer wire. Okay. So initially there was an EMF E naught, but now an unknown EMF E is balanced at a length small l of the potentiometer wire. So let's say this is your unknown EMF E that is balanced. This is the galvanometer at a length small l. This is the length small l of the wire. Okay. So what will be the EMF E? This EMF. So that EMF will be equal to potential gradient into this small length L. Okay. So potential gradient, let's put the value. Potential gradient is equal to E naught R upon R1 plus R into capital L. Okay. This was the potential gradient into this length small l. This will be the EMF, unknown EMF. So let's match with the options. Which option is the correct one? Option number D, E naught R by R plus R1 into small l by capital L. Okay. Option D will be the correct answer. Now question number 32 says a proton and an alpha particle both enter a region of uniform magnetic field B, moving at right angles to the field B. If radius of circular orbits for both the particles is equal and the kinetic energy acquired by the proton is 1 MeV, then the energy acquired by the alpha particle will be. Okay. So we have a proton and an alpha particle which enter a uniform magnetic field B. So we know that whenever a particle enters a uniform magnetic field, then the radius of the particle can be expressed as mv by qb, where mv is the momentum, so it can be written as p by qb. And we also know that the momentum p is equal to under root 2m k, so the radius can be written as under root 2m k by qb. K is the kinetic energy, kinetic energy, or we can simply write energy. So K is the energy. Now R is equal to under root 2mk by qb. So from here we can find the value of K. K will be equal to R square Q square B square by 2m, right? That means K, that means the energy is proportional to Q square by m. Okay, because it is given that they have the same radius, right? The radius is equal, radius of the circular orbits is equal, so r is equal, and that means r is constant, and then magnetic field is also same, so that will also be constant for both. Only q and m will vary, so k is proportional to q square by m, right? Now the energy acquired by the proton, that means kp is given as 1 MeV, and we have to find the energy acquired by the alpha particle, that means K alpha. So K alpha by Kp will be equal to Q alpha by Qp square into Mp by M alpha, because M is on the denominator side. So let's put the values. The ratio of charges of alpha particle and proton will be 2 by 1. So 2 by 1 square. And the ratio of masses of proton and alpha particle will be 1 by 4. Okay, so this is equal to 4 into 1 by 4, that means 1. Okay, so K alpha by Kp is equal to 1. So K alpha, that means energy acquired by the alpha particle, will be equal to 1 into Kp, and Kp was given 1 MeV. So 1 into 1 MeV, that means 1. Okay, 1 MeV will be the energy acquired by the alpha particle as well. So option B will be the correct answer. Now question number 33. A rectangular coil of length 0.12 meter and width 0.1 meter having 50 turns of wire is suspended vertically in a uniform magnetic field of strength 0.2 Weber per meter square. The coil carries a current of 2 ampere. If the plane of the coil is inclined at an angle of 30 degree with the direction of the field, then the torque required to keep the coil in stable equilibrium will be. Okay. So the length of the coil is 0.12 meter and the width or the breadth is equal to 0.1 meter, right? So what will be the area? It will be length into breadth, that means 0.12 into 0.1 meter square. So the area will come out to be 0.012 meter square. This is the area. What else is given? Number of turns is 50. So N is equal to 50. Then the magnetic field B is given as 0.2 Weber per meter square. And the current I is given as 2 ampere. Theta is 30 degree, right? The plane of the coil is inclined at an angle 30 degree with the direction of the field. So the theta is 30 degree. We have to find the torque required to keep the coil in stable equilibrium. So the required torque will be equal to NIAB sine theta. This is the formula. Okay, you have to remember this formula. N is the number of turns, that means 50, into current I, that means 2 ampere. Then A is area, so area is 0.012 meter square. Then the magnetic field B is given as 0.2 Weber per meter square, and then sine 30 degree. Okay, sine 30 degree. So when you will solve this, you will get 0.20 and the unit of the torque will be Newton meter. So 0.20, that means option D will be the correct answer. Let's come to question number 34, and the question says a series RC circuit is connected to an alternating voltage source. Consider two situations. First, when capacitor is air filled, and second, when capacitor is mica filled. Current through the resistor is I and the voltage across capacitor is V. Then we have to choose the correct option out of the given ones. Okay. So in the first case, the capacitor is air filled. That means in the first case, there is no dielectric, and let's assume that the capacitance in this case is Ca. In the second case, mica filled, capacitor is mica filled, that means in this case dielectric is present. Dielectric is present, and if the capacitance in this case is Cb, then we know that Ca will be less than Cb, because in the second case the capacitance will increase due to the introduction of the dielectric. Okay, so let's write it down here. When dielectric is introduced, then the capacitance increases. Therefore, Cb will be more than Ca. And we know that capacitance is equal to charge by voltage or potential. So C is inversely proportional to V, right? That means since Ca is less than Cb, so Va will be more than Vb. Okay, because C and V are inversely proportional. So let's choose the correct option. Option number D, Va more than Vb, will be the correct answer. Next question says an electron moves on a straight line path xy as shown The ABCD is a coil adjacent to the path of the electron. What will be the direction of current, if any, induced in the coil? Okay. So what will happen when electron will come towards the loop, then the magnetic flux will increase, and when this electron will move away from this loop, then the same magnetic flux will decrease. Okay, same amount of magnetic flux will decrease. So the induced current will be opposite to each other. So the correct answer will be option A. The current will reverse its direction as the electron goes past the coil. Okay, so as the electron is approaching the coil, what will happen? Magnetic flux will increase, and when it will move away from it, then the same amount of magnetic flux will decrease. Therefore, we can say that the direction of the current will reverse. So option A will be the correct answer. Question number 36. The energy of EM waves is of the order of 15 keV. To which part of the spectrum does it belong? Option A, ultraviolet rays, option B, gamma rays, option C, X-rays, and option D, infrared rays. So this is a direct question. We know that the range of X-rays, okay, energy of X-rays is 100 eV to 100 keV. So this 15 keV falls in this range. Therefore, option C, X-rays, will be the correct answer. Question number 37 is from the chapter Wave Optics, and the question is, at the first minimum adjacent to the central maximum of a single slit diffraction pattern, the phase difference between the Huygens wavelet from the edge of the slit and the wavelet from the midpoint of the slit is. So we have a single slit. Suppose this is the single slit, this is point P and this is point Q. Here we have a screen. This is the central maximum. Now, one wave will go from here, from P, another from Q, and this point O where they meet is the first minimum adjacent to the central maximum. Okay. Now, if we assume that R is the midpoint of P and Q, then another wave from this midpoint will also go. Right. We have to find the phase difference between the wavelet from the edge of the slit and the wavelet from the midpoint of the slit. So let's see. First, we'll find the phase difference between PO and QO. Okay. And then we'll find the phase difference between PO and RO. That means in the second case, we have to consider the midpoint. Okay. So PO and RO. And then we have to find the difference between these two. Right. So for the first one, we'll find the path difference. So we know that the path difference between PO and QO will be equal to lambda. Okay, that path difference is equal to lambda because A sine theta is equal to lambda. So what will be the phase difference? Phase difference between PO and QO will be equal to 2 pi by lambda into the path difference. So 2 pi by lambda into lambda, that means 2 pi. So for the first case, the phase difference is 2 pi. Now, if we consider the midpoint R, so this time we have to find the phase difference between PO and RO. Okay, so first path difference between PO and RO is equal to half the path difference of the first case. That means this time it will be lambda by 2. Okay, because we are considering the midpoint, so the wavelength will also be half of the first case. So lambda by 2. Then what will be the phase difference? Phase difference between PO and RO will be equal to 2 pi by lambda into the path difference, that means into lambda by 2. So this time the phase difference will be equal to pi. Okay, so in the first case the phase difference was 2 pi and in the second case it is pi. Now we just have to find the difference between these two. So the phase difference between PO and QO minus the phase difference between PO and RO is equal to 2 pi minus pi, that means pi, and the unit will be radian. So pi radian will be the answer. Option number A will be the correct answer. Question number 38 is from the chapter Ray Optics and Optical Instruments, and the question is, a beam of light consisting of red, green and blue colors is incident on a right angled prism. The refractive index of the material of the prism for the above red, green and blue wavelengths are 1.39, 1.44 and 1.47 respectively. The prism will, option A, not separate the three colors at all, Option B, separate the red color part from the green and blue colors. Option C, separate the blue color part from the red and green colors. And the last option is separate all the three colors from one another. So we'll check which color will undergo total internal reflections and which color will not. Okay. So this will tell us that whether the colors will be separated or not. So let's check the angle of incidence first. So this is your right angle prism, right? This is the 90-degree angle and this is the 45-degree angle here. Okay. Here the rays are incident, also making an angle 90 degree with this surface, with the first surface. So when they are incident on the other surface, here they will make 45-degree angle because this is corresponding to this angle. Okay, these two are corresponding, so this will also be 45-degree. Now we have to find out the angle of incidence. So let's draw the normal. This is the normal. Normal, that means 90-degree angle with this surface, right? Out of which first part is 45-degree. Okay, this half is 45-degree, so the other half will also be 45-degree, and this other half is the angle of incidence. So the angle of incidence is equal to 45-degree. Now we have to check total internal reflection. So we know that for total internal reflection to take place, the angle of incidence must be greater than the critical angle IC. And IC, sine IC is equal to what? 1 by mu, right? Where mu is the refractive index of the material. So I should be greater than IC. So sine I should also be greater than sine IC, right? Sine I will be equal to sine 45-degree. That means 1 by root 2. It should be greater than sine IC. That means 1 by mu. So 1 by root 2 should be greater than 1 by mu. That means mu should be greater than root 2. Okay. The refractive index of the color should be greater than root 2 for total internal reflection to take place. Okay. And root 2 is equal to 1.414. That means mu should be greater than 1.414. Then total internal reflection will take place. Otherwise, it will not take place. Okay. So let's check for different colors. For the first color, that is red color, its refractive index is given as 1.39. 1.39. So is it less than root 2 or more than root 2? It is less than root 2. Okay, it is less than 1.414. That means total internal reflection will not take place. No total internal reflection. Then for the green color, the refractive index is given as 1.44. 1.44. Now this 1.44 is greater than 1.414. It is greater than root 2. So in this case, total internal reflection will take place. Okay. That means green color will not emerge out of the prism. And then the next color is blue color. For this, the refractive index is given as 1.47, which is again greater than root 2. It is greater than 1.414. So in this case also total internal reflection will take place. So for green and blue, total internal reflection will take place. That means these color will not emerge out of the prism, whereas red color will come straight. Okay, it will move straight and then it will emerge outside the prism. Okay, red color, not blue color. So this color. So what do we conclude here? We conclude that it will separate the red color part from the green and blue colors. Okay. Option B will be the correct answer. Question number 39 is from the chapter Ray Optics and Optical Instruments, and the question is, in an astronomical telescope in normal adjustment, a straight black line of length L is drawn on inside part of the objective lens. The eyepiece forms a real image of this line. The length of this image is I. The magnification of the telescope is. So we have an objective lens. This is your objective lens. Objective lens. And here we have an eyepiece. Okay. Then in normal adjustment, a straight black line of length L is drawn on inside part of objective lens. So on inside part of objective lens, suppose this is the line that is drawn and the length of this line is L. Okay. Then what happens? The eyepiece forms a real image. So the image that will be formed will be real and inverted. Okay. And the length of this image is I. So we can say that the height of the object is height of the object. What is the object here? The line that is drawn on inside part of the objective lens. Okay, that line will act as the object. So its height will be L. Okay, And what will be the height of the image? It will be minus I, because it is inverted, so we have put a minus sign. Okay. Then we know that in normal adjustment, what is the length of the telescope? The length of telescope will be equal to FO plus FE. Okay, what is the length? The total distance between the eyepiece and the objective lens is the length of the telescope. So that is equal to FO plus FE, right? And what will be the object distance in this case? The object distance from the eyepiece will be equal to minus FO plus FE. Okay. Why? Because the object distance will be this distance between the objective lens and the eyepiece. Okay, because the object is located just on the objective lens. Okay, so this total distance will be the distance of object, and minus sign because we are measuring from the eyepiece towards the left side. Okay, so this is the object distance. Now we have to find out the magnification. So we know that magnification is equal to height of the image, that means minus I, upon the height of the object, that means L. And in terms of focal length, it can be written as FE upon FE plus UE. Okay, UE is what? The distance of object from the eyepiece. So this is the distance of object from eyepiece minus FO plus FE. So we can put that here, FE upon FE minus FO minus FE. Okay, we have put UE equals to minus FO plus FE. So if we solve this, FE will be cancelled. So what will be left? We have FE upon minus FO equals to minus I by L. So minus sign is on both the sides, it can be cancelled. FE upon FO is equal to I by L. But we have to find the magnification of the telescope, and magnification of the telescope is equal to FO upon FE. So what will be the value of FO upon FE? That will be equal to L by I. Okay, so L by I, option number B will be the correct answer. Question number 40 is from the chapter Wave Optics, and the question is, two slits in Young's experiment have widths in the ratio 1:25. The ratio of intensity at the maxima and minima in the interference pattern I maximum by I minimum is. Okay, so we know that in general the ratio of the intensities I1 by I2 is equal to the ratio of the widths. Okay, that means it will be equal to 1/25. Now we have to find the I maximum by I minimum. So that will be equal to under root I1 plus under root I2 upon under root I1 minus under root I2 whole square. Okay. Now in order to simplify this, we'll divide the numerator and denominator by root I2. So dividing the numerator and denominator by root I2, we get, what do we get here? We'll get under root I1 by I2 plus 1 upon under root I1 by I2 minus 1. Okay, and square of this. Now we know that I1 by I2 is equal to 1/25. So we just have to put the values. Okay, so here we get 1 by under root 1/25 plus 1. Here we get under root 1/25 minus 1 and square of this. So 1/25 will be equal to 1/5. So 1/5 plus 1, and here 1/5 minus 1 whole square. Now you can easily solve this. Okay, on the numerator side we'll get 5 plus 1, that means 6/5, and on the denominator side we'll get minus 4/5. Okay, minus 4/5. So 5 will be cancelled, and here we'll get 6/4 square. So it will be minus 3/2 square. That means it will be 9 by 4. Okay, minus will become plus because on squaring minus becomes plus. So 9 by 4 will be the correct answer, option number C. Question number 41 is from the chapter Dual Nature of Radiation and Matter, and the question is, a photoelectric surface is illuminated successively by monochromatic light of wavelength lambda, and lambda by 2 is missing here, okay, and lambda by 2. If the maximum kinetic energy of the emitted photoelectrons in the second case is 3 times that of the first case, then the work function of the surface of the material is, okay, H is the Planck's constant, C is the speed of light. So basically it is said that a photoelectric surface is illuminated 2 times, first by using the light of wavelength lambda and second by using the light of wavelength lambda by 2. Okay, the maximum kinetic energy in the second case is 3 times that in the first case. Okay, so first let's find out the maximum kinetic energy in the first case. We know that K max is equal to hc by lambda minus the work function phi naught. Okay, so in the first case it will be K max 1 equals to hc by lambda minus phi naught. Okay, in the second case K max 2, the wavelength is lambda by 2. So this time it will be hc by lambda by 2 minus phi naught, that is equal to 2 hc by lambda minus phi naught. So this is the maximum kinetic energy in the second case. Now this second one is 3 times the first one. Okay, so K max 2 is 3 times the K max 1. So we just have to put the values, then we can find out the value of the work function. K max 2 is 2 hc by lambda minus phi naught, and this side we have 3 times K max 1, right? 3 times hc by lambda minus phi naught. So 2 hc by lambda minus phi naught equals to 3 hc by lambda minus 3 phi naught. So we can say that minus phi naught plus 3 phi naught, that means 2 phi naught, is equal to 3 hc by lambda minus 2 hc by lambda, that means hc by lambda. Okay, so phi naught will be equal to hc by 2 lambda, right? So this is the work function, hc by 2 lambda. Now let's see the options. Option number C will be the correct answer. Now this question is again from Dual Nature of Radiation and Matter, and the question says light of wavelength 500 nanometer is incident on a metal with work function 2.28 electron volt. The de Broglie wavelength of the emitted electron is, okay. So first of all, what will be the energy of the incident ray? That will be equal to 12,400 divided by lambda in terms of angstrom, okay, and the unit will be electron volt. So these are some of the formulas that you have to remember. Okay, 12,400 divided by the wavelength in terms of angstrom. So the wavelength is given as 500 nanometer, so it can be written as 5,000 angstrom. Okay, so let's put this value here, 12,400 divided by 5,000 angstrom, and the unit will be electron volt. So if you solve it, you'll get 2.48 electron volt. This is the energy of the incident ray. Now we'll find the maximum kinetic energy. So the maximum kinetic energy is equal to the energy of this incident ray minus the work function phi naught. Okay, so 2.48 eV minus the work function that is given as 2.28 electron volt in this question. So 2.28 electron volt. So when you subtract this, you'll get 0.2 electron volt. This is the maximum kinetic energy. Now why we have calculated maximum kinetic energy? Because we know that the minimum de Broglie wavelength can be h by under root 2m into maximum kinetic energy. Okay, h by under root 2m kinetic energy maximum is equal to the minimum wavelength of the emitted electron. Okay, so let's put the values. H, that means Planck's constant, is equal to 6.63 into 10 to the power minus 34 divided by under root 2 into m. M is the mass of the electron, that is 9.1 into 10 to the power minus 31 into maximum kinetic energy is 0.2 electron volt. That means 0.2 into the electronic charge 1.6 into 10 to the power minus 19. Okay, so this is going to be a lengthy calculation. You'll have to solve this, and when you'll solve this, you'll get 2.75 approximately into 10 to the power minus 9. Okay, so you can say it is approximately 2.8 into 10 to the power minus 9. Now this is the minimum wavelength of the emitted electrons. Okay, the wavelength cannot be less than this. So any wavelength, the de Broglie wavelength of the emitted electron will be more than this. Okay, so it should be more than 2.8 into 10 to the power minus 9 meter. Option A will be the correct answer. Question number 43 is from the chapter Nuclei, and the question is: a nucleus of uranium decays at rest into nuclei of thorium and helium. Then, option A, the helium nucleus has more momentum than the thorium nucleus. Option B, the helium nucleus has less kinetic energy than the thorium nucleus. Option C, the helium nucleus has more kinetic energy than the thorium nucleus. And the last option is the helium nucleus has less momentum than the thorium nucleus. So basically two things are compared, momentum and kinetic energy, between helium and thorium nucleus. Okay, so initially we had uranium nucleus which decays into thorium and helium. Okay, so the uranium nucleus before decay was at rest. That means its momentum was 0. Okay, momentum for uranium was 0. And we know that in case of decay process, the total momentum remains conserved. Momentum is conserved. That means the momentum before decay is equal to the momentum after decay. And before decay it is 0 because uranium was at rest. After decay, the momentum of the thorium is P thorium plus the momentum of the helium will be P helium. So the sum of the momentum of thorium and helium is 0. Okay, so we can say that the momentum of the thorium is equal to minus momentum of the helium. That means the amount is same. Magnitude of the momentum is same, only the direction will be different. Okay, so the first option will be incorrect. The helium nucleus has more momentum than the thorium nucleus because the momentum will be same, the only direction will be different. Okay, and the last option will also be incorrect. Okay, no one has more or less momentum. Now we come to the kinetic energy. So we know that kinetic energy is equal to p square by 2m, and we have seen that the momentum is same for both. That means kinetic energy will be inversely proportional to the mass. And mass of thorium is greater than the mass of helium, right? Therefore, the kinetic energy of thorium will be less than the kinetic energy of the helium. Okay. So, which one will have more kinetic energy? Helium will have more kinetic energy. So, let's see. Second option is the helium nucleus has less kinetic energy, which is incorrect because we have seen that helium will have the more kinetic energy. Okay. So, option C, helium nucleus has more kinetic energy than thorium nucleus will be correct. Okay, option C will be the correct answer. Question number 44 says, in the spectrum of hydrogen, the ratio of longest wavelength in the Lyman series to the longest wavelength in the Balmer series is. Okay, so this is very simple. We know that 1 by L, that means wavelength, 1 by wavelength is equal to R 1 by N1 square minus 1 by N2 square. Okay, now for Lyman series, specifically for the longest wavelength in the Lyman series, we can say that N1 is equal to 1 and N2 is equal to 2. Okay, in this case, the wavelength is longest. So, 1 by lambda of the Lyman series will be equal to R 1 by 1 square minus 1 by 2 square. So, this will be equal to 3R by 4. Okay, now for Balmer series, for the longest wavelength, N1 should be equal to 2 and N2 should be equal to 3. So 1 by lambda of the Balmer series will be equal to R 1 by 2 square minus 1 by 3 square. That means 1 by 4 minus 1 by 9. So here we'll get 5R by 36. Okay, so we have to find out the ratio, right? Ratio of the longest wavelength in the Balmer series, Lyman to Balmer. Okay, so we have to find out the lambda L by lambda B. Okay, so lambda L by lambda B will be equal to 4 by 3R into 5R by 36. Okay, so let's solve it. R will be cancelled. 4 into 9 is 36. So 5 by 27. That means option B will be the correct answer. Now question number 45 says that the input signal given to a CE amplifier having a voltage gain of 150 is Vi equals to 2 cos 15t plus pi by 3. The corresponding output signal will be. Okay. So we know that for a CE CE transistor, the phase difference between the input and output signal is pi. That means 180 degree, right? Now here input signal is given, voltage gain is given, we have to find the output signal. Okay, so we know that the voltage gain, this is the voltage gain, is equal to output voltage divided by the input voltage. We have to find the output voltage, so output will be equal to voltage gain into the input voltage. Okay, both are given, we have to multiply, but in the angle, in this pi by 3 of this input voltage, the phase difference will also get added. Okay, so voltage gain is 150 into the input voltage is 2 cos 15t plus pi by 3, and what will get added? The phase difference will get added here, that means pi will get added here. Okay, so let's solve it. 150 into 2, that means 300. So 300 cos, inside the bracket you will get 15t plus pi by 3 plus pi, that means 4 pi by 3. So this is the output signal or the output voltage. So let's match with the options. 300 cos 15t plus 4 pi by 3, option B will be the correct answer. And the last question is from semiconductor electronics, and the question is, in the given figure, a diode D is connected to an external resistance R equals to 100 ohm and an EMF of 3.5 volt. If the barrier potential developed across the diode is 0.5 volt, then the current in the circuit will be. So here you can see that the applied voltage, that means this EMF, is more than the barrier potential. So this diode is forward biased. So the current will flow like this, and the potential difference across the resistance, will be equal to 3.5 volt minus 0.5 volt. So this will be equal to 3 volt. Now we have to find the current in the circuit. So current I in the circuit will be equal to potential difference upon the resistance. So potential difference is 3 volt and the resistance is 100 ohm. So on solving this, you'll get 0.03 ampere. Options are in milliampere, so you can write it as 30 milliampere. So option C will be the correct answer. Okay. So here we complete all the physics questions from NEET 2015 re-exam paper. We'll be back with another session very soon. Till then, keep learning, keep scoring high. For a better understanding, I would suggest you to practice same questions from our website www.examsnet.com, and for more information, you can download our app from the link given in the description box. Thank you so much. Hey champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So in today's session, we are going to discuss NEET 2015 chemistry paper, and we have a total 45 questions here. So let's start the session. The first question is from some basic concepts of chemistry, and the question is, what is the mass of the precipitate formed when 50 ml of 16.9% solution of silver nitrate is mixed with 50 ml of 5.8% NaCl solution? Here the atomic masses are given. Okay. So what is given here? We have a 16.9% solution of silver nitrate. So it means that in 100 ml solution, what is the mass of silver nitrate? The amount of silver nitrate is 16.9. Okay. This is what 16.9% solution of silver nitrate means. Okay, but it is given that here we have 50 ml of solution. Okay, so in 100 ml solution the amount of silver nitrate will be 16.9 grams. So in 15 ml solution, what will be the amount of silver nitrate? It will be half of 16.9 grams, that means 8.45 grams. Okay, so according to this question we have 8.45 grams of silver nitrate. Similarly, we have 5.8% NaCl. So we can find out the amount of NaCl also. In 100 ml solution, the amount of NaCl will be 5.8 grams. So since we have 50 ml solution here, so the amount of NaCl will be half of 5.8 grams, that means 2.9 grams. So these are the amounts of silver nitrate and NaCl. Now what will be the number of moles? Let's find out the number of moles. Number of moles of silver nitrate will be the given mass divided by the molar mass. Okay, so 8.45 grams divided by the molar mass of silver nitrate. What is the molar mass of silver nitrate? It is 170. Okay, almost 170. Why? Because the atomic mass of silver is 107.8, then nitrogen 14 and 3 times oxygen, that means 48. So if you add them up, you will get 169 point something. So I have written 170. So the number of moles that will get is 0.049. This is the number of moles. Now what will be the number of moles of NaCl? Given mass by molar mass. So given mass for this is 2.9 grams. And the molar mass of NaCl will be 58.5. Okay, sodium 23 and chlorine 35.5. So it will be 58.5, and on dividing it you will get again 0.049. So these are the number of moles of silver nitrate and NaCl used in the reaction. Now let's write down the reaction here. Silver nitrate is mixed with NaCl. So what do we get? We'll get a precipitate of silver chloride. This is the precipitate. We have to find the amount of this precipitate, silver chloride. In addition to this, sodium nitrite will also be formed. Sorry, sodium nitrate. Okay. Now let's see. Initially, what is the number of moles of silver nitrate? 0.049. We have just calculated. And the number of moles of NaCl is also 0.049. Number of moles of the products will be 0. After the reaction, the number of moles of silver nitrate and NaCl will be 0, and that of products will be 0.049 of each. Okay, so we have to find the amount of silver chloride. So the amount of silver chloride or mass of silver chloride, that is the precipitate here, will be number of moles into the molar mass. So number of moles is 0.049 and the molar mass of silver chloride will be 143.5. So on solving this, you'll get 7 point something. So it will be 7 grams. So the correct answer will be option number B. Now the next question is again from mole concept, and the question is, if Avogadro number Na is changed from 6.022 into 10 to the power 23 per mole to 6.022 into 10 to the power 20 per mole, then this would change. Option A, the mass of 1 mole of carbon. Option B, the ratio of chemical species to each other in a balanced equation. Option C, the ratio of elements to each other in a compound. And option D, the definition of mass in units of grams. So the answer will be the mass of 1 mole of carbon. Okay. Others will not be affected by change in Avogadro number. What is Avogadro number? Avogadro number is the number of atoms in 1 mole. Okay. So here it is given that the Avogadro number is changed from 6.022 into 10 to the power 23 per mole to 6.022 into 10 to the power 20 per mole. Okay. So what is the mass of 1 mole of carbon? Mass of 1 mole of carbon. It is 12 grams, right? 1 mole of carbon means 6.022 into 10 to the power 23 atoms of carbon, right? So it is 12 grams. Now what will be the mass of 1 atom of carbon? 1 atom, it will be 12 divided by 6.022 into 10 to the power 23 grams. Okay. Now if Avogadro number becomes 6.022 into 10 to the power 20 per mole, then what will be the mass of 1 mole? Okay. That means we have to find out the mass of 6.022 into 10 to the power 20 atoms of carbon. Okay, so this will be equal to 12 divided by 6.022 into 10 to the power 23. That means mass of 1 atom of carbon. This is the mass of 1 atom of carbon into, now the number of atoms is 6.022 into 10 to the power 20 grams. Okay. So now on solving this, we'll get 12 into 10 to the power minus 3 grams. So you can see that initially when the Avogadro number was 6.022 into 10 to the power 23, then the mass of 1 mole of carbon was 12 grams. Now if it is changed to 6.022 into 10 to the power 20 per mole, then the mass of 1 mole of carbon becomes 12 into 10 to the power minus 3 grams. That means the mass of 1 mole of carbon has changed. Therefore, option A will be the correct answer. Question number 49 is again from some basic concepts of chemistry. And the question is, the number of water molecules is maximum in. Options are 1.8 gram of water, then 18 grams of water. Third one is 18 moles of water, and the last one is 18 molecules of water. Okay. So let's see, we know that the number of molecules can be calculated by multiplying the number of moles with the Avogadro number. Okay. So let's check one by one. In the first one, we have 1.8 grams of water. So the number of moles will be 1.8 grams divided by the molecular mass of water, that is 18. So number of moles will be 0.1. Now what will be the number of molecules? Number of molecules will be equal to number of moles, that means 0.1, into Avogadro number 6.023 into 10 to the power 23. Okay. So it will be equal to 6.023 into 10 to the power 22. Now let's check the second one. Here we have 18 grams of water. So the number of moles will be equal to 18 divided by 18. So it is 1. Okay. Number of moles is 1. Now what will be the number of molecules? Number of moles, that means 1 into Avogadro number 6.023 into 10 to the power 23. So it will be exactly equal to the Avogadro number, that means 6.023 into 10 to the power 23. So we can see that the second one has more number of molecules as compared to the first one. Okay. So till now the second one is maximum. Now let's check the third one. Here we have 18 moles. So the number of moles is already given here. So the number of molecules will be number of moles, that means 18 into Avogadro number 6.023 into 10 to the power 23. So this is 18 times the Avogadro number. That means it is 18 times that of the second one. Okay. So till now the second one had maximum number of molecules, but now the third one has maximum number of molecules because it is 18 times the second one. Okay. Now the last one, it is already given that it has only 18 molecules. 18 molecules only, which is very less as compared to the third one. So the third one, that means option number C, will have the maximum number of molecules of water. So option C is the correct answer. Question number 50 is from the chapter D and F block elements, and the question is, which is the correct order of increasing energy of the listed orbitals in the atoms of titanium? Atomic number is 22. Okay, so we know that the electronic configuration of titanium is 1s2, 2s2, 2p6, then 3s2, 3p6, 4s2, and then 3d2. Okay, this is how we write the electronic configuration. So till 2p6 it is not mentioned in the options. Okay, it is mentioned 3s onwards. So here we can see that 3s, then 3p will come, then 4s will come, and then 3d will come. Okay, this is the correct order of increasing energy. Okay, so 3s, then 3p, then 4s, then 3d. That means option number C. Okay, this is 3d. Okay, here 3d. So option C will be the correct answer. Question number 51 is from the chapter Chemical Bonding and Molecular Structure, and the question is, in which of the following pairs both the species are not isostructural? So let's see the options. The first one is diamond and silicon carbide. Here we know that these two are network solids, isn't it? Network solids. And in these solids, the carbon has tetrahedral structure. Okay, tetrahedral structure in both diamond as well as silicon carbide. So these are isostructural. Now in the second option we have ammonia, that is NH3 and PH3. So let's see the structure of ammonia. So this is nitrogen. 3 hydrogens are bonded to it like this. And one lone pair is present on nitrogen. Now if we see PH3, that is phosphine, so phosphorus, and similarly 3 hydrogens are bonded to phosphorus here also in the same way. Okay, and one lone pair of electron on the phosphorus atom. So in both these species the hybridization is sp3 and the shape is pyramidal. Okay, so both have pyramidal shape. So these are also isostructural, that means having same structure. Now the third one is xenon tetrafluoride and xenon tetraoxide. So let's see the structure. First, xenon tetrafluoride. This is xenon. Now 4 fluorine atoms are bonded to it like this. And then in addition, xenon has 2 lone pair of electrons on it. Okay. So here the hybridization will be sp3d2 and the shape is square planar. Square planar shape. The second species of this option is xenon tetraoxide. So xenon. Now 4 oxygen here are bonded in a different way. One oxygen here, then another oxygen. This is the third oxygen and this is the fourth oxygen. So as you can see here the hybridization is sp3 and the shape is tetrahedral. So it is clear from here that these two species are not isostructural. Okay, they have different structures. So option C will be the correct answer. These are not isostructural. Still, let's see the fourth one also. Okay, so in option D we have silicon tetrachloride. That means silicon here, 3 chlorine atoms like this and 1 chlorine atoms here. Okay, so this is sp3 hybridization. and tetrahedral shape. And the second option is the second species of this option is PCl4 plus. Okay, so P plus and then 4 chlorine atoms in the same way. Okay, so this is also sp3 hybridized with tetrahedral shape. Okay, so in the last option both the species have tetrahedral structure. So these are also isostructural. The only option in which species are not isostructural is the third one. So option C will be the correct answer. Question number 52 is from the chapter Chemical Bonding and Molecular Structure, and the question is decreasing order of stability of O2, O2 minus, O2 plus and O2 2 minus is. Okay, so we have to find the correct decreasing order of the stability of these species. Now for this we should know that stability is related to bond order of the species. Okay, higher the bond order of the species, greater will be its stability. So they have direct relation. These are directly related to each other. Okay. Now according to this, the correct answer will be the last option, option number D. Okay. Let's see how. We know that bond order is equal to half number of bonding molecular orbital minus number of anti-bonding molecular orbitals. Okay. So now to find out the number of bonding and anti-bonding molecular orbitals, you should know how to write the electronic configuration. So I'm assuming that you already know that. Here O2 plus, here the number of bonding molecular orbital will be 10 and that of anti-bonding molecular orbital will be 5. So here the bond order will be half 10 minus 5, that means half into 5, so 2.5. So bond order for this is 2.5. Then the next one is O2. So for this number of bonding molecular orbital will be 10 and that of anti-bonding molecular orbital will be 6. So it will be half into 4, that means 2. Then O2 minus, for this number of bonding molecular orbital is 10 and anti-bonding molecular orbital 7. So it will be half into 3, that means 1.5. And the last one is O2 2 minus. It is half number of bonding molecular orbital 10 and number of anti-bonding molecular orbital will be 8. So half into 2, that means 1. So as you can see that from O2 plus to O2 2 minus, the bond order is decreasing. 2.5, then 2 for O2, then 1.5 for O2 minus, and then 1 for O2 2 minus. Therefore, option D will be the correct answer. Okay, it is the correct decreasing order of the stability of these species. Similarly, you can find for any given species. Okay, so here option D is the correct answer. Question number 53 is from the chapter States of Matter, and the question is a gas such as carbon monoxide would be most likely to obey the ideal gas law at option A low temperatures and high pressures, option B high temperatures and high pressures, option C low temperatures and low pressures, and the last option is high temperature and low pressure. So we know that a real gas shows ideal gas behavior at high temperature and low pressure. Okay, because when the temperature is high and the pressure is very low, then the molecules are very far apart from each other. Okay, molecules are far apart from each other, so there is no intermolecular collisions, no intermolecular collisions, and due to this the gas will behave ideally. Okay, so option D high temperature and low pressure will be the correct answer. Question number 54 is from thermodynamics, and the question is the heat of combination of carbon to carbon dioxide is minus 393.5 kilojoule per mole. The heat released upon formation of 35.2 grams of carbon dioxide from carbon and oxygen gas is. Okay, so it is given in the question that heat of combination of carbon to carbon dioxide is minus 393.5 kilojoule per mole. That means when carbon is combined with oxygen in order to form carbon dioxide, then what is the amount of heat released? The heat released during this process is equal to 393.5 kilojoule. Okay, so it means that for the formation of 1 mole of carbon dioxide, okay, minus 393.5 kilojoule per mole means for the formation of 1 mole of carbon dioxide, this is the amount of heat released. Minus sign simply shows that the heat is released. Okay, so how much heat is released? 393.5 kilojoule. Here we'll not put the minus sign because minus sign is the indication that heat is released, not absorbed. Okay. Now we have to answer what will be the amount of heat released when 35.2 grams of carbon dioxide will be formed. Okay. So for the formation of 1 mole of carbon dioxide. 1 mole of carbon dioxide, that is, what is the mass of 1 mole of carbon dioxide? 44 grams. So we can say that for the formation of 44 grams of carbon dioxide, the amount of heat released is 393.5 kilojoule. So for the formation of 35.2 grams of carbon dioxide, the amount of heat released will be 393.5 divided by 44 into 35.2 kilojoule. Okay. So we have used simple unitary method here. And on solving this, you'll get almost 315. So 315 kilojoule of heat will be released when 35.2 grams of carbon dioxide is formed. Okay. So option A will be the correct answer. Question number 55 says, what is the pH of the resulting solution when equal volumes of 0.1 molar NaOH and 0.01 molar HCl are mixed? Okay, so let's write down the reaction first. We have NaOH, that is a strong base, and we have HCl, that is a strong acid. So both will neutralize each other completely and they will give NaCl plus water as the product, right? Now, concentration of NaOH is 0.1 molar. And we know that concentration is equal to number of moles divided by volume. So what will be the number of moles? It will be equal to concentration into volume. We don't know the volume. Concentration of NaOH is 0.1 molar. So its number of moles will be equal to zero point 0.1 into V. V is the volume. Okay. Number of moles is concentration into volume. Concentration is 0.1 molar and volume is V. Similarly, for HCl, number of moles will become 0.01 into V. Volumes are same, okay? It is given equal volumes. So, its number of moles will be 0.01 into V. And the initial concentration of the products will be 0. Now, what will be the final number of moles? So, final number of moles of NaOH will be 0.09 V because here HCl is present in less amount, NaOH is present in more amount, right? So the one that is present in less amount will completely disappear. So HCl will completely disappear and the same amount will disappear from the larger one also. Okay, that means 0.01 V has disappeared from HCl. So the same amount will disappear from NaOH also. So what amount of NaOH will left unreacted? 0.09 V. Okay. So what will be the final product, final number of moles of the products? It will be 0.01 V of each because the same amount had been, same number of moles had been disappeared from the reactants. So they will appear on the product side now. Okay. Got it? Now this NaOH that is left unreacted, that is 0.09 V, will dissociate into OH minus and Na plus, right? So after the reaction, it will be 0 and the number of moles of OH minus and Na plus will be 0.09 V each. Got it? Now, here it is given that equal volumes of these two had been mixed. So the final volume of the solution will be V plus V, that is 2V, right? And the final number of moles of OH minus ion is 0.09 V, right? So what will be the final concentration of OH minus? It will be equal to number of moles divided by volume, right? So 0.09 V divided by 2V. V will get cancelled and it will be equal to 0.045. This is the final concentration of OH minus ion. Got it? So what we have got? We have got the concentration of OH minus ion, that is equal to 0.045. So we can find out the value of POH. POH is equal to minus log the concentration of OH minus ion, right? That means minus log 0.045. Okay, so we can write it like this, minus log 4.5 into 10 to the power minus 2, okay, to simplify. So it will be 2 minus log 4.5. Now what will be the value of log 4.5? We know that log 4 is approximately equal to 0.6 and log 5 is approximately equal to 0.67. So log 4.5 will be somewhere in between. Okay, so let's say 0.65. Okay, so it will be 2 minus 0.65, that will be equal to 1.35. So this is the POH, but what we have to find? We have to find pH. Okay, so we know that pH plus POH is equal to 14. So from here we can find pH. pH will be equal to 14 minus POH, that is 1.35. So 14 minus 1.35 will be equal to 12.65. So this will be the pH. Let's see the options. 12.65 is option number D. So this is the pH of the resulting solution. Option D is the correct answer. Question number 56 is from the chapter Chemical Kinetics, and the question is, if the equilibrium constant for N2 plus O2 gives 2NO is K, then the equilibrium constant for half N2 plus half O2 gives NO will be. Okay, so we can see that in the second reaction, the first reaction has been multiplied by half. So what will happen to the equilibrium constant? The resulting equilibrium constant will get the power half. Okay. Therefore, the correct answer will be option number D, K to the power half. Question number 57 can be related to electrochemistry, and the question is, aqueous solution of which of the following compounds is the best conductor of electric current? Options are hydrochloric acid, ammonia, fructose and acetic acid. So it is very clear that hydrochloric acid is a strong acid, right? It is a strong acid. That means it completely gets dissociated into H plus and Cl minus ions. Okay, it completely gets dissociated into H plus ion and Cl minus ion. This is the reason this will act as a strong electrolyte. Strong electrolyte. That's why it is the best conductor of electric current. Okay, so option A will be the correct answer. Other options, that means ammonia, fructose and acetic acid, these are non-electrolytes. These are non-electrolytes. So the correct option is only option number A. Question number 58 is from the chapter Equilibrium, and the question is, which one of the following pairs of solution is not an acidic buffer? Okay, so we know that an acidic buffer is a mixture. Let's write it down here. It is a mixture of weak acid and its salt. That means salt of weak acid with a strong base. With a strong base. That means the acid here should be a weak acid. Okay, and if you look at the options, you can see that the first three acids that are given here, acetic acid CH3COOH, second one is H2CO3 and the third one is H3PO4. All these are weak acids. whereas the last one, that means HClO4, is a strong acid. Therefore, it will not form acidic buffer. It will not form an acidic buffer, because in order to form an acidic buffer, weak acid should be present. Therefore, option D will be the correct answer. That means it is not an acidic buffer. Question number 59 is from the chapter Organic Chemistry, Some Basic Principles and Techniques. And the question is, which of the following statements is not correct for a nucleophile? So what is a nucleophile? It is a species that provides electron, right? That means it is an electron-rich species. Now let's see the options. The first statement says that ammonia is a nucleophile. Yes, this is the correct statement. The second statement says nucleophiles attack low electron density sites. This is also correct because they provide electrons at the sites where the electron density is low. Then the third statement says nucleophiles are not electron seeking. Yes, they don't seek electron, they provide electron. So this is also correct. The last statement says nucleophile is a Lewis acid. So this is incorrect because we know that Lewis acids are electron deficient species. These are electron deficient compounds, not electron rich. But nucleophile is electron rich. That means it is a Lewis base, not Lewis acid. So the last statement is incorrect. That means option D will be the correct answer. Question number 60 is from the chapter Alcohols, Phenols and Ethers. And the question is, which of the following is not the product of dehydration of this compound? So this is an alcohol. Okay. Now if it undergoes dehydration, then first of all, a carbocation will be formed. Okay. So let's see. Here there will be an H plus ion. This OH will accept this H plus ion to form the carbocation. So let's see how it will be formed. Here this O will have two hydrogens now. Okay, and there will be a plus charge. So this is the carbocation. If we draw the simple structure of the carbocation, it will be a cyclic ring here, and at this position we have a plus charge. Okay, so this is the simple structure of the carbocation. Carbocation, that will be the intermediate of the reaction. Now in the next step, one of the alpha hydrogens will be removed and three different types of products can be formed depending on which alpha hydrogen has been removed. Okay, so how many alpha hydrogens are there? Three alpha hydrogens are there. So let's say this is alpha hydrogen number 1 at this position. Then there is another alpha hydrogen at this position. So let's say this is alpha hydrogen number 2, and the third alpha hydrogen is at this position. Okay, so this is alpha hydrogen number 3. So in each case a different product will be formed. Suppose alpha hydrogen number 1 is removed, then the product will be something like this. Here we will have a double bond at this position. Okay, then if alpha hydrogen number 2, that means this one, is removed, then we will have double bond at a different location. So it will be at this position. Okay, so this is the second type of product that can be formed. Now the third type of product will be formed if alpha hydrogen number 3, that means this one, is removed. So let's see. This is the cyclic ring, and this time we will have a double bond here. Okay, so these are the three types of products that are possible here. So let's see the options. In the first option, we don't have any of these products, so this cannot be possible. The second option, this is given here, this one. Okay, then in the third option we have this product, and in the last option we have the last product that we have discussed. So the first one is not possible. Okay, option A will be the correct answer. This is not the product of dehydration of the given alcohol. Question number 61 says, 2,3-dimethyl-2-butene can be prepared by heating which of the following compounds with a strong acid? So if we look at the options, you can see that in all the options alkenes are mentioned. Okay, so we have to check which alkene will give 2,3-dimethyl-2-butene on reacting with a strong acid. Okay, so for that we should know the concept. When an alkene reacts with strong acid, what happens? In the first step, there will be formation of a carbocation. Okay, carbocation. Why? Because there will be attack of proton at the double bond and it will lead to the formation of a carbocation. Then in the next step, either it will rearrange itself or there will be direct elimination of hydrogen. So in the last step, there will be always elimination of hydrogen and it will lead to the formation of another type of alkene. Okay, so let's check one by one. You have to remember this. Now in the first option we have CH3 thrice. That means 3 methyl groups are attached to this carbon. So let's write it like this. Okay. Then CH double bond CH2. Right. Now what we have discussed in the first step, there will be attack of a proton at the double bond. It will lead to the formation of a carbocation. So the carbocation that will be formed will look like this. 3 methyl groups to this carbon. Then here CH positive charge and then single bond CH3. Okay, this is the carbocation that is formed. In the next step, we have discussed that either there can be rearrangement or direct elimination of hydrogen. So in this case, a rearrangement is possible because there is an alkyl group adjacent to the carbocation. So an alkyl shift will take place. It will get attached to the carbocation. Okay. And from where it is shifted, at that position a positive charge will develop. So in the next step, an alkyl shift will take place. Alkyl shift will take place. So what will be formed? CH3, C, CH3, and here a positive charge will develop and alkyl group will get shifted to the next carbon. So CH, CH3. Okay, and then at last we have CH3. Now we have to neutralize this carbocation. So in this, what will happen? Elimination of hydrogen will take place now. Elimination of hydrogen will take place. So this hydrogen will get eliminated to give the final product. So let's see, the final product will look like this: CH3C, CH3. Then here we have C, CH3, and then at last CH3. This is the final product. Okay. So as you can see, the first step was formation of carbocation and the last step is elimination of hydrogen. So what is the name of this product? This is 2,3-dimethyl 2-butene. And this is the same product that is mentioned in the question, isn't it? That means option A is correct answer. It is giving 2,3-dimethyl 2-butene on reacting with a strong acid. So we have already got our correct answer, but still we can check one more option. Okay. So let's check the second one. First we'll separate these. If we check the second one, this is CH3 twice. Okay. So two methyl groups are attached to this carbon. CH3, CH3. Then we have double bond CH, then CH2, CH3. This is the alkene that is mentioned in the second option. So like in the previous case, here also a proton attack will take place at the double bond to form the carbocation. So let's see what carbocation is formed. CH3, C, CH3. Here positive charge will develop. Here single bond CH2. Okay. And then CH2, CH3. This is the carbocation formed. The process is same as the first one. But in this case, there is no alkyl shift because there is no alkyl group present adjacent to the carbocation. Okay. So here there will be direct elimination of hydrogen. So this hydrogen will be eliminated. So CH3, this is CH2. Okay. This will become CH2. Then C, CH3, CH2, CH2, and then CH3. Here a double bond will develop. So this is the final product. But this is not 2,3-dimethyl 2-butene. So this is not the correct answer. Okay. Similarly, you can check for other two options as well. You should practice yourself. So here we have got the correct answer, option A. Okay. Question number 62 is from the chapter Hydrocarbons, and the question is, in the reaction with HCl, an alkene reacts in accordance with the Markovnikov's rule to give a product 1-chloro-1-methyl cyclohexane. The possible alkene is. Okay. So first of all, what is Markovnikov's rule? According to this rule, when a protic acid, let's write it down here, when a protic acid, that is HX, is added to an asymmetric alkene, an asymmetrical alkene, then what happens? The acidic hydrogen is attached, that means it gets itself attached to the carbon having more number of hydrogens, having more number of hydrogens. Okay, so the acidic hydrogen will get attached to that carbon which is having more number of hydrogen atoms, whereas the halide group will get attached to the carbon having less number of hydrogens, or we can say the halide group will get attached to the more substituted carbon, more substituted carbon. Okay, so let's see. We have to form 1-chloro-1-methyl cyclohexane. So let's draw the structure of 1-methyl 1-chloro cyclohexane. This is your cyclohexane. Now 1-chloro and 1-methyl, that means at the first carbon, chlorine group is also attached and methyl group is also attached. Okay, this is the product that has to be formed. Now let's check. In the first option, we have a double bond here. So two carbons are there at the end of the double bonds. So one carbon is this and the other is the carbon having H2. So to which of the carbon the hydrogen will get attached and to which one of the carbon halide group will get attached. So according to the rule, the acidic hydrogen will get attached to the carbon having more number of hydrogen, that means this one. It will get attached to this one and it will become CH3. Whereas the halide group, that means chloride group, will get attached to this carbon. Okay, so it will form the similar product. Okay, this one will be formed. So yes, this is possible. Now let's check second option. Here we have double bond at this position. So we have one carbon here and the other carbon here. So which one is having less number of hydrogen? This one. Let's say this is carbon number 1, this is carbon number 2. So carbon number 1 is having less number of hydrogen because it is more substituted. Okay. So here chloride will get attached, whereas hydrogen will get attached to carbon number 2. So it will form a product like this. Here double bond will be removed. Here hydrogen will be attached at carbon number 2. Here we already have CH3 and one chloride group will also get attached. Okay. So this option is also giving the desired product. Okay. So A and B both are giving the desired product. Let's check the last option. Here the double bond is present at this location. So this is symmetric alkene. Okay. Both the carbons are having same number of hydrogens. Okay. This is not asymmetric. Also, if chloride group get attached to this position or this position, any one of them, it is not giving the desired product. Okay, because in the desired product we have to have chlorine at the first carbon only. So D is not possible. Only first and second options are correct. That means option number C, A and B both. This will be the correct answer. Question number 63 says that the possible stereo structures of CH3, CHOH, COOH which are optically active are called. Okay. So options are atropisomers, enantiomers, mesomers and diastereomers. Now let's see the structure of the given compound. We have this carbon here. Then we have methyl group CH3. Then we have H and OH. And the other group is carboxyl group. Okay, COOH. Now it is given that these are optically active. That means it can be rotated. So if it rotates, the resulting structure will look something like this. This OH will come this side and hydrogen will come this side. Okay. Other things will remain same. CH3 and COOH. Now as you can see that these two structures are mirror images of each other, isn't it? And these are non-superimposable, because if you put one of them on the other, it will not superimpose the other. Okay, so we can say that these are non-superimposable mirror images. Okay, now out of the given options, mesomers cannot be the correct answer because mesomers are not optically active. These are not optically active. But the compounds which are mentioned in the question are optically active. So mesomers can be eliminated from here. Others are optically active. But in atropisomers, there are no chiral carbons. There are no chiral carbons. But if you look at the structure, you can see that the central carbon is chiral carbon because all the four groups attached to it are different. Okay, so this is a chiral carbon here. So one more option is eliminated. Now out of enantiomers and diastereomers, the correct answer will be enantiomers because diastereomers are non-mirror images. Okay, these are non-mirror images. But the given compound is mirror image. Okay, these are mirror images. So the correct answer will be option number B, enantiomers, which are non-superimposable mirror images. So the correct answer will be option number B. Question number 64 is from the chapter Haloalkanes and Haloarenes, and the question is, in an SN1 reaction on chiral centers, there is option A, inversion more than retention leading to partial racemization, option B, 100% retention, option C, 100% inversion, and the last option is 100% racemization. So we know that in an SN1 reaction, first a carbocation is formed. Okay, carbocation is formed, that is planar. So here the attack of nucleophile can take place from either side, resulting in the mixture of products. Okay, one due to the inversion and the other due to retention. Okay, so it will lead to the inversion as well as retention. Both will take place here. Retention means the product will have the same configuration, and the inversion means that it will have inverted configuration. Okay, so this will not be 100% retention, this will not be 100% inversion, it will be the mixture of both. That means it will be racemization. Okay, but the amount of products formed due to inversion and retention will not be same. Okay, that means there will not be 50% of each, so it is not 100% racemization. In fact, what happens, the amount of product formed as a result of inversion will be slightly more as compared to that due to retention. Okay, so it will lead to partial racemization, so option A will be the correct answer. Question number 65 is from the chapter Alcohols, Phenols and Ethers, and the question is, reaction of phenol with chloroform in the presence of dilute sodium hydroxide finally introduces which one of the following functional group? Okay, so we have phenol. Let's draw the structure here. This is phenol. Okay, then it has to react with chloroform, that means CHCl3 in the presence of dilute sodium hydroxide, NaOH. Okay, so this reaction is an example of electrophilic substitution reaction, and the name of this reaction is Reamer-Tiemann reaction. Okay, it is Reamer-Tiemann reaction. So you must have read about this reaction. This is one of the very important reactions. Okay. So we know that this reaction is used for the formation of salicylaldehyde. So the product of this reaction will be salicylaldehyde. Here we'll have OH, and at this position, at the ortho position, we'll have an aldehyde group, CHO. Okay. So the correct answer will be option number C, CHO. This group will be finally introduced. Okay. Next question is again from alcohols, phenols and ethers, and the question is, which of the following reactions can be used for the preparation of alkyl halides? Okay, so if you look at the given reactions, you can see that the reactant in each case is an alcohol that is reacting with hydrochloric acid. Okay, so it will lead to the formation of alkyl halides, that means alkyl chlorides in this case, because the chloride group Cl will replace the OH group. Okay, now here we should remember that reaction with HCl and anhydrous zinc chloride, this combination is known as Lucas reagent, right? Lucas reagent. So reaction of alcohol with this leads to the formation of alkyl halides, and this is used for primary, secondary and tertiary alcohols all. Okay, but out of primary, secondary and tertiary alcohols, only tertiary alcohols can undergo reaction in the absence of zinc chloride. Undergo the reaction in the absence of zinc chloride, because the reactivity of tertiary alcohol is more. Okay, it has a high reactivity, so it does not require the presence of zinc chloride to undergo the reaction, whereas primary and secondary alcohols are less reactive. These are less reactive, so they require the presence of zinc chloride as catalyst to undergo the reaction and give the product alkyl halide. Okay, now let's see the reactions. The first reaction, you can see that the alcohol given here is primary alcohol, okay, 1 degree alcohol, and here zinc chloride is present. So although primary alcohol is less reactive, but the presence of zinc chloride as catalyst will make the reaction easy, and it will lead to the formation of the product that will be alkyl chloride. So it will be CH3, CH2, Cl. This will be formed, and in addition water molecule will be formed. Okay, so here alkyl halide can be prepared. Now in the next reaction, the which type of alcohol is present here? Here again primary alcohol is there. Okay, but in this case zinc chloride is absent. Okay, in the second reaction. So we know that primary and secondary alcohol will not undergo the reaction in the absence of zinc chloride. So here no reaction can take place. Then in the third one we have a secondary alcohol. Okay, sorry, this is a tertiary alcohol. In the third reaction we have a tertiary 3 degree alcohol, and here zinc chloride is absent, but we know that 3 degree alcohol can undergo the reaction even in the absence of zinc chloride, so it will lead to the formation of the product. Okay, CH3 C CH3 CH3. Okay, tertiary alcohol, it will lead to the formation of this alkyl chloride and water molecule will be formed. So this will also form alkyl halides. And in the last reaction we have a secondary alcohol, okay, 2 degree alcohol. 2 degree alcohol and the presence of zinc chloride. So this will also lead to the formation of the product. So the product will be CH. Here 2 methyl groups are there, and here Cl. In addition water molecule. So you can see that only second reaction is not leading to the formation of alkyl halide. Others are giving the alkyl halides. That means 1, 3 and 4 only. Option D will be the correct answer. Now question number 67 is from some basic concepts of chemistry, and the question is 20 grams of magnesium carbonate sample decomposes on heating to give carbon dioxide and 8 grams magnesium oxide. What will be the percentage purity of magnesium carbonate in the sample? Okay, so according to this question, magnesium carbonate will be heated and it will decompose to give two products, carbon dioxide and magnesium oxide. So let's write down the reaction first. We have magnesium carbonate. It is heated and it will give two products, magnesium oxide and carbon dioxide. Now what is the molar mass of magnesium carbonate? If you add the atomic masses of magnesium, carbon and 3 oxygens, you will get 84 grams. Okay, so 84 grams is the molar mass of magnesium carbonate, and the molar mass of magnesium oxide is 40 grams. That means 84 grams of magnesium carbonate will give 40 grams of magnesium oxide. In the question it is given that 20 grams of magnesium carbonate is used. So 20 grams of magnesium carbonate will give what amount of magnesium oxide? Simple unitary method, 40 divided by 84 into 20 grams. Okay. So on solving this you'll get 9.52 grams of magnesium oxide. So this much magnesium oxide should be formed. But in the question it is given that the actual yield was only 8 grams. Okay, 8 grams magnesium oxide is formed. But ideally 9.52 grams should be formed. So what will be the percentage purity of magnesium carbonate? Percentage purity will be 8 divided by 9.52 into 100. Okay, on solving this you'll get 84%. So this is the percentage purity of magnesium carbonate. Option number C, 84, will be the correct answer. Question number 68 is from S block elements, and the question is, on heating, which of the following releases carbon dioxide most easily? Okay, so here in the options you can see we have metal carbonates. Now we know that carbonates, let's write it down here, become thermally stable down the group. Okay, this is one point, and the other point is that in general alkali metal carbonates are more stable than the alkaline earth metal carbonates. Alkaline earth metal carbonates. So out of the 4 options, sodium and potassium are alkali metals, so their carbonates will be more stable. Okay, they will be more stable. Sodium carbonate and potassium carbonate will be more stable as compared to the alkaline earth metal carbonates. Okay, now the second and third options, these are alkaline earth metal carbonates, but magnesium comes first. Okay, on moving down the group, calcium comes later, so calcium will be more stable as compared to the magnesium carbonate. Okay, calcium carbonate will be more stable than the magnesium carbonate, because on moving down the group it will become more stable. So option B will be the correct answer. It will release the carbon dioxide most easily because it is least stable out of the given options. Now question number 69 is from the chapter hydrocarbons, and the question is, the oxidation of benzene by V2O5 in the presence of air produces. Options are malic anhydride, benzoic acid, benzaldehyde and benzoic anhydride. Okay, so let's see, we have a benzene. So this is the benzene. Okay, now it is reacting with V2O5. For this reaction, very high temperature and very high pressure are used. Let's say around 773 Kelvin temperature is used. Now in this reaction, 2 molecules of carbon dioxide will be removed and 2 molecules of water will also be removed. Okay, so out of 6 carbons of benzene, 2 carbons have been removed in the form of carbon dioxide. So how many carbons will be left? Only 4 carbons, and the resulting product will look something like this: CH, double bond CH, then carboxylic group attached to each of the carbons. Okay, so this is the intermediate and it is known as malic acid. Malic acid. Now the reaction will proceed further and one more molecule of water will be removed from here. So let's say this OH and one of the hydrogen from the other carboxyl group will be removed. So the resulting product will be CH, double bond CH, and here we have carbons, CO, and one more oxygen is there. Okay. So this will be the final product that is known as malic anhydride. Malic anhydride. So the correct answer will be option number A, malic anhydride. Question number 70 is from the chapter Aldehydes, Ketones and Carboxylic Acids. And the question is, reaction of a carbonyl compound with one of the following reagents involves nucleophilic addition followed by elimination of water. The reagent is, okay. So we have a carbonyl compound, carbon double bond oxygen, okay. And it will react with one of the reagents and the reaction will involve elimination of water, okay, and it will be a nucleophilic addition reaction. Now if we look at the options, here hydrazine in presence of feebly acidic solution, it is possible. Next option is hydrocyanic acid, so this involves addition but it does not involve elimination of water. Third one is sodium hydrogen sulfate. The reaction of carbonyl compound with this also does not involve elimination of water. And with Grignard reagent also only addition reaction takes place, no elimination of water. So in B, C and D there will be no elimination of water. Elimination of water. Elimination of water is possible only in the first case. So the reaction will look like this. This is carbonyl compound plus we have hydrazine NH2 NH2, okay. Then it will lead to the formation of the product. This is carbon double bond N single bond NH2, okay. So this will be the product formed. So option A, hydrazine in the presence of feebly acidic solution, will be the correct answer. Next question is again from aldehydes, ketones and carboxylic acids, and the question is, which one of the following esters gets hydrolyzed most easily under alkaline conditions? Okay, so you can see in each of the options we have a benzene ring, then we have carbonyl group also there, and in addition there are substituents, okay, different types of substituent attached to the benzene ring. For example, in the first one we have H3CO here. In the second one, we don't have anything. In the third one, we have chlorine. Okay, in the second one, you can assume there is hydrogen. Third one, we have chlorine. And in the last one, we have NO2. So, we have to find out which one of the given esters will get hydrolyzed most easily under alkaline condition. That means the attack of OH minus will be easiest in which one of them. Okay, so you can see that out of the substituents that are attached to the benzene ring, NO2 group is most electron withdrawing in nature. Okay, it is electron withdrawing in nature. Okay, so it will withdraw the electron density from the carbonyl carbon and thus it will facilitate the attack of OH minus ion. Okay, it will withdraw electron density from carbonyl carbon, okay. So it will facilitate the attack of OH minus ion, therefore it will get hydrolyzed most easily. So option D will be the correct answer. Question number 72 is from the chapter amines, and the question is, the following reaction is known by the name. So if you look at the reaction, you can see that one of the products is amine, second one is benzoyl chloride, okay, benzoyl chloride, and as a result an amide is formed. So here benzoyl group has been added to the amine, right? This is simply benzoylation and the specific name of this reaction is Shorten-Baumann reaction, okay? So option C will be the correct answer. Next question is again from the chapter amines, and the question is, method by which aniline cannot be prepared is. First option is degradation of benzamide with bromine in alkaline solution. So here we are talking about Hofmann bromamide degradation reaction. Okay, Hofmann's bromamide degradation reaction. We know that when degradation of an amide takes place with bromine in alkaline solution, then a primary amine is formed. Okay, so since here the amide is benzamide, so as a result the primary amine will be aniline. Okay, so in this case aniline will be formed. Then in the next one we have reduction of nitrobenzene with hydrogen or palladium in ethanol. So here, yes, nitro group will be replaced by the amino group and it will lead to the formation of aniline. So here also aniline will be formed. In the third one, we have potassium salt of phthalimide treated with chlorobenzene followed by hydrolysis with aqueous NaOH solution. Okay, so here phthalimide is treated with chlorobenzene, which is an aryl halide. We know that when the reaction of phthalimide takes place with an alkyl halide, in that case the aniline will be formed. But here we have aryl halide, so no reaction will take place. Okay, so here aniline will not be formed. In the last option we have hydrolysis of phenyl isocyanide with acidic solution. So this will also lead to the formation of aniline. Only in the third one aniline is not being formed. Okay, so using this method you cannot prepare aniline. Yes, if you use alkyl halide in place of aryl halide, then you can prepare aniline, but not using aryl halide. So option C is the correct answer here. Question number 74 is again from the chapter amines, and the question is the number of structural isomers possible from the molecular formula C3H9N is. So let's check the degree of unsaturation first. Okay, degree of unsaturation. So here we'll try to check whether the compound can be unsaturated. That means whether there can be multiple bonds. So here the formula for this is carbon plus 1, number of carbon plus 1 minus number of hydrogen plus number of halogen minus number of nitrogen divided by 2. Okay, so in this compound you can see in the molecular formula we don't have any halogen, so we can write the formula without halogen. It will be number of carbon plus 1 minus number of hydrogen minus number of nitrogen divided by 2. So let's put the numbers. Number of carbon here is 3 plus 1 minus number of hydrogen is 9 minus number of nitrogen is 1 divided by 2. So here we'll get 4 minus 4, that is 0. So degree of unsaturation is 0. That means there are no pi bonds here. All single bonds are present. All single bonds. Okay, the compound is not unsaturated. None of the compound is unsaturated. So let's see what is the possible structure. So the first structural isomer can be 3 carbons in straight chain, 3 hydrogens attached to this, 2 hydrogens to the second carbon, 2 hydrogens to this one, and then NH2. Okay, so as we can see, this is a primary amine. This is one of the structural isomers. Then one more type of primary amine can be formed, CH3, CH and methyl group attached to this carbon, and then NH2. This is also primary amine, that is 1 degree amine. Then let's see, secondary amine can be formed, CH3, NH, CH2, CH3. Okay, so this is a secondary amine, and then the last type that can be formed is a tertiary amine. So CH3, then N, and then 2 methyl groups again. Okay, so 3 methyl groups attached to nitrogen. So this is a tertiary amine. So these are the possible structures, because only single bonds are present, so only these can be the possible structural isomers. So 4 types of structural isomers are possible. So option D, 4 will be the correct answer. Question number 75 is from the chapter polymers, and the question is caprolactam is used for the manufacture of. Options are Teflon, Terylene, nylon 66 and nylon 6. So the correct answer will be nylon 6. Okay, let's see the structure. Caprolactam. The structure is something like this. Here we have nitrogen attached to hydrogen. Here we have double bond oxygen. This is your caprolactam. Caprolactam. Now when it is heated at 533 to 543 Kelvin, then the product that is formed is nylon 6. Okay, it get polymerized. Here we have carbon double bond oxygen, CH2 5, then NH. So this polymer is formed. This is known as nylon 6. So option D, nylon 6 will be the correct answer. Question number 76 is from the chapter solid state, and the question is the vacant space in BCC lattice unit cell is. Okay, so we know that in case of BCC lattice, the packing efficiency is 68%. Okay, 68%. Therefore, what will be the vacant space? Vacant space will be equal to 100 minus packing efficiency. That means 100 minus 68, that is equal to 32. Okay, so 32% will be the vacant space. Option number C will be the correct answer. Question number 77 is again from solid states, and the question is the correct statement regarding defects in crystalline solids is. Option A, Frenkel defects decrease the density of the crystalline solids. So what is Frenkel defects? It is a type of dislocation defect. Dislocation defect. So what happens in Frenkel defect? Smaller ions, mainly cations. Okay. So small cations are dislocated from their normal sites to the interstitial sites. Okay. To the interstitial sites. Okay. These cations are small in size. So here, although the position of the cation changes, but the density, overall density remains same. Okay, so it does not affect the density of the crystalline solids. So this is incorrect statement. Now the next statement says that Frenkel defect is a dislocation defect. Yes, we have already discussed. So this is a correct statement. The third statement says Frenkel defect is found in halides of alkaline metals. This is incorrect statement because we have seen that in case of Frenkel defects, small cations are dislocated from their normal sites into the interstitial sites. But in case of halides of alkaline metals, what happens? The cations are of larger size. Cations are larger in size, therefore they cannot fit in the interstitial spaces. They cannot fit into interstitial spaces. And this is the reason Frenkel effect is not possible in these halides. Then the last statement says Schottky defects have no effect on the density of the crystalline solids. This is also incorrect because Schottky defects decreases the density of the crystalline solids. Okay, in this case the density decreases. So the only correct statement is the second statement. So option B will be the correct answer. Question number 78 is from some basic concepts of chemistry, and the question is what is the mole fraction of the solute in a 1 molar aqueous solution? So here we have 1 molar aqueous solution. Small m means molality. Okay, molality is given here. And what is molality? We know that molality means the number of moles of solute, number of moles of solute in 1 kg of solvent. 1 kg of solvent. Now here we have 1 molar aqueous solution, that means solvent is water. Okay, so according to this we can say that there is 1, the number of mole of solute is 1. Okay, 1 mole solute in 1 kg of water. 1 kg of water. So we know that the number of moles of solute is 1. Let's say that A is solute and B is water. Okay. So number of moles of A is 1, and what will be the number of moles of B, that is number of moles of water? It will be equal to given mass of water, divided by the molar mass of water. So given mass of water is 1 kg, that is 1000 grams, and the molar mass of water is 18 grams. So here we get 1000 divided by 18, that means 55.5. So this is the number of moles of B, that is water. Now we have to find the mole fraction of the solute, that means we have to find XA. So that is equal to number of moles of solute divided by number of moles of solute plus number of moles of solvent. So number of moles of solute is 1, and number of moles of solute plus solvent will be 1 plus 55.5. So here we get 1 by 56.5. On solving this, we'll get 0.0177. So the correct answer will be option number C. Question number 79 is from the chapter Chemical Kinetics, and the question is, the rate constant of the reaction A to B is 0.6 into 10 to the power minus 3 moles per liter per second. If the concentration of A is 5 molar, then the concentration of B after 20 minutes is. Okay. So let's write down the reaction here. A is the reactant, B is the product. Okay. Now the concentration of A at time t equals to 0 is 5 molar according to this question, and the concentration of B will be 0. Now after 20 minutes, t equals to 20 minutes, suppose x molar has been decreased from A. So 5m minus x. So what will be the amount of, or the concentration of B? It will increase by x molar. So it will become x molar. Okay. X molar has been decreased from A and it is increased in B. So the concentration of B becomes x molar after 20 minutes. Okay. Now we have to find the value of this x, because the question is asked what is the concentration of B after 20 minutes. That means we have to find the value of this x. Right. Now if we look at the unit of the rate constant, it is moles per liter per second. This is the unit of a zero order reaction, of the rate constant in zero order reaction. So we can say that this reaction is zero order reaction. And moles per liter denotes molarity. Okay, because the definition of molarity is number of moles of solute in 1 liter of the solution. So moles per liter denotes molarity. So in place of moles per liter, we can write simply capital M, that means molarity. So the rate constant K is given as 0.6 into 10 to the power minus 3 capital M per second. Okay. Now for zero order reaction, the value of x is equal to k into t. There is a derivation for this that you have to know. So x is equal to k into t. We have to find the value of x. So the value of k is 0.6 into 10 to the power minus 3 molar per second, and the value of time here is 20 minutes. That means if we convert it into seconds, it will be 1200 seconds. So 1200 seconds. So seconds and per second will cancel out. Here we'll get 0.72 molar. This is the value of x. That means this will be the concentration of B after 20 minutes. So option C, 0.72 molar will be the correct answer. Question number 80 is from the chapter P block elements, and the question is, the stability of +1 oxidation state among aluminium, gallium, indium and thallium increases in the sequence. So these are group 13 elements, and we know that group 13 elements mainly exhibit +3 and +1 oxidation state. Okay. Now the stability of, let's write it down here, the stability of the lower oxidation state, that means +1 oxidation state, increases on going down the group, Therefore the stability of +1 oxidation state will be aluminium, then gallium, then indium, and then thallium. Okay. So this will be the sequence of stability of oxidation state. So which option will be the correct answer? Option A will be the correct answer. Question number 81 is again from P block elements, and the question is the variation of the boiling points of the hydrogen halides is in the order maximum hydrogen fluoride, then in the decreasing order hydrogen iodide, then hydrogen bromide, and then hydrogen chloride. What explains the higher boiling point of hydrogen fluoride? Option A. There is strong hydrogen bonding between hydrogen fluoride molecules. Option B. The bond energy of hydrogen fluoride molecules is greater than in other hydrogen halides. Option C. The effect of nuclear shielding is much reduced in fluorine, which polarizes the hydrogen fluoride molecule. And the last option is the electronegativity of fluorine is much higher than for other elements in the group. So what is the sequence of these elements? First fluorine, then chlorine, then bromine, and then iodine. Okay, so this is the sequence on moving down the group. And we know that on moving down the group, in general, the boiling point increases. Okay, the boiling point increases on going down the group. Going down the group. We are talking about the boiling points of hydrogen halides. Okay, so according to that, the sequence should be minimum for hydrogen fluoride. Okay, then more than that hydrogen chloride, then more than that hydrogen bromide, and then it should be maximum for hydrogen iodide. This should be the trend according to the general rule, but here hydrogen fluoride plays an exceptional role. Okay, this is exceptional. The reason is that due to the high electronegativity of fluorine, hydrogen fluoride forms strong intermolecular hydrogen bonding. Okay, there is very strong intermolecular hydrogen bonding. Okay, so this is the reason why the boiling point of hydrogen fluoride will be maximum among all the other hydrogen halides. Okay, so this has the maximum, this comes on the top. Okay, so due to this the sequence becomes like this: hydrogen fluoride maximum, and then according to the general trend, that means hydrogen iodide, then hydrogen bromide, and then hydrogen chloride. Okay, only hydrogen fluoride is exceptional. So the correct answer will be option number A. There is strong hydrogen bonding between hydrogen fluoride molecules. Now next question is also from P block elements, and the question is strong reducing behavior of H3PO2, that is hypophosphorus acid, is due to option A. High electron gain enthalpy of phosphorus, option B. High oxidation state of phosphorus, option C. Presence of two OH groups and one pH bond, and option D. Presence of one OH group and two pH bonds. So let's see the structure of H3PO2. We have a phosphorus in the center, we have double bond oxygen, then single bond hydrogen, and then single bond OH. Okay, so you can see it has two pH bonds, not one pH bond. So option C is definitely eliminated from here. Now the main reason is that all the oxy acids of phosphorus which have pH bonds, phosphorus and hydrogen bonds, they act as reducing agents. They act as strong reducing agents. Now since this H3PO2 has two pH bonds, okay, it has two pH bonds, therefore it will act as a very strong reducing agent. Okay, so option D will be the correct answer: presence of one OH group and two pH bonds. Question number 83 is from the chapter Classification of Elements and Periodicity in Properties, and the question is the formation of the oxide ion O2- from oxygen atom requires first an exothermic and then an endothermic step as shown below. In the first step, oxygen gains an electron to form O- ion, and this process is exothermic. Okay. Then in the second step, O- gains another electron to form O2-, and this process is endothermic. Thus, the process of formation of O2- in gas phase is unfavorable even though O2 minus is isoelectronic with neon. It is due to the fact that option A, O minus ion has comparatively smaller size than oxygen atom. Option B, oxygen is more electronegative. Option C, addition of electron in oxygen results in larger size of the ion. And option D, electron repulsion outweighs the stability gained by achieving noble gas configuration. So the question says that O2 minus has the same electronic configuration as that of neon, and neon is a noble gas. Okay, so O2 minus has the noble gas configuration. So it should be the process of the formation of O2 minus should be favorable, right? Because this is very stable, but it is not so. Okay, this is unfavorable, even though it is having the electronic configuration same as that of a noble gas. So why? The reason is that when oxygen atom accepts an electron, this reaction is easy. Okay, oxygen atom easily accepts an electron, but when it forms O minus. Now in the next step, this O minus has to receive an electron. Now O minus is already negative and it has to accept an electron which is another negative species. So this will cause the repulsion. Okay, this will cause electron repulsion. Electron repulsion, and this electron repulsion will be so strong that it will outweigh the stability that is gained by achieving the noble gas configuration. So the answer will be option number D. Electron repulsion outweighs the stability gained by achieving noble gas configuration. This is why the formation of O2 minus will be unfavorable. Next question says, which of the statements given below is incorrect? So let's read the statements. The first statement says O3 molecule is bent. O3 means ozone. Okay. And this statement is correct because the structure is bent. Okay. It looks like this. This is one oxygen, double bond oxygen, and one single bond oxygen. So this is a bent molecule. So this is correct statement. Then the second statement says ONF is isoelectronic with O2N. Isoelectronic means same number of electrons. Okay, same number of electrons. And this is also correct because each one ONF as well as O2N minus have 24 electrons each. Okay, they have same number of electrons, so this is also correct. Then the third statement says OF2 is an oxide of fluorine. Now this is an incorrect statement because we know that if we compare the electronegativity of oxygen and fluorine, fluorine is more electronegative than oxygen. More electronegative than oxygen. Therefore, this OF2 is known as fluoride of oxygen. Okay, this is known as fluoride of oxygen, not oxide of fluorine. So option C is incorrect. And the last statement says Cl2O7 is an anhydride of perchloric acid. This is also correct statement. So we had to identify the incorrect statement. So it will be the third one. That means option C will be the correct answer. Question number 85 is from the chapter General Principles and Processes of Isolation of Elements, and the question is, in the extraction of copper from its sulfide ore, the metal is finally obtained by reduction of cuprous oxide with. So for the extraction of copper from its sulfide ore, the process that we use is roasting. Okay, so it will react with oxygen to give the oxide. Okay, and the sulfide ore of copper that are generally used are copper pyrites. So let's see the reaction. CuFeS2, copper pyrite. It will react with oxygen, right? It will give copper sulfide Cu2S and FeS. Now these two products that are obtained will further react with oxygen because this reaction is being performed in the presence of excess of air. Okay, so this Cu2S, copper sulfide, will react with oxygen to give cuprous oxide, and FeS will give FeO. Okay, so now we have got the oxides of these metals. Now in the next step, what happens, this copper sulfide and this cuprous oxide, will react with each other. So let's see what happens. Copper sulfide plus cuprous oxide will react with each other. In this process, this copper sulfide will act as the reducing agent, and this process is known as auto reduction. Auto reduction. So this copper sulfide will reduce copper oxide into the copper metal. So it will give copper metal plus sulfur dioxide. Okay. So we can see that this metal copper is obtained finally by the reduction of cuprous oxide with which metal? Copper sulfide. So this copper sulfide is the answer. Copper 1 sulfide. Option B will be the correct answer. Question number 86 is from the chapter D and F block elements, and the question is, assuming complete ionization, same moles of which of the following compounds will require least amount of acidified potassium permanganate for complete oxidation? Okay, so we know that potassium permanganate acts as the oxidizing agent. Okay, it oxidizes the compounds. Now here it is given that all the given compounds have same number of moles. Okay, so number of moles are same. Now we have to see which one will require least amount of potassium permanganate for complete oxidation. So let's see, in the first one we have FeSO3. So this Fe2 plus will get converted into Fe3 plus ion. Okay, and then the second part is SO3. So in this case what will happen? SO3 2 minus will get converted into SO4 2 minus. Okay, so two types of oxidation has to be done by the potassium permanganate here. In the second one, again iron is there, so in this case also Fe2 plus will get converted into Fe3 plus, and then the other part is C2O4. So this will also get oxidized, so C2O4 2 minus will get converted into carbon dioxide, CO2. Okay, now in the third one, again first part is iron, so Fe2 plus is getting converted into Fe3 plus, and then NO2. So this NO2 minus is getting converted into NO3 minus. Okay, after complete oxidation, these will be the products. Okay, now in the last one, Fe2 plus is getting converted into Fe3 plus. So this part is same. The first part is same for all. Only the second part varies. And the other part is sulfate. So this is SO4 2 minus. Now it will not undergo oxidation because here the sulfur is already in its maximum oxidation state. Maximum oxidation state, that is +6 oxidation state. So it will not undergo further oxidation. Not undergo further oxidation. That means here least amount of potassium permanganate will be required because only the first part has to get oxidized. The second part does not require potassium permanganate for oxidation. So it will be the easiest to oxidize. So option D will be the correct answer. Question number 87 is again from D and F block elements, and the question is, gadolinium belongs to 4F series. Its atomic number is 64. Which of the following is the correct electronic configuration of gadolinium? So it's very easy. The electronic configuration of gadolinium will be xenon, then 4F7, 5D1 and 6S2. Option B will be the correct answer. Question number 88 is from the chapter Coordination Compound, and the question is, the sum of coordination number and oxidation number of the metal M in the complex where En is ethylene diamine is. Okay, so this complex is given and we have to find the sum of coordination number and oxidation number. So let's find the oxidation number and coordination number one by one, and then we'll find the sum. So oxidation number, suppose the oxidation number of M, that is metal, is X. So X plus En, that is ethylene diamine, is a neutral ligand. Okay, this is a neutral ligand. So its oxidation number will be 0. Then we have C2O4. C2O4 has the charge 2 minus. So its oxidation number will be -2. And then we have chlorine. Its oxidation number is -1. So let's find out the sum. We know that the sum will be equal to 0, right? This is the general rule. So X minus 2 minus 1 equals to 0. Then we have x minus 3 equals to 0. So from here we can find out that x is equal to plus 3. So the oxidation number of the metal is plus 3. Oxidation number of the metal M is plus 3. Now we'll find the coordination number. So coordination number means number of the binding sites. Number of binding sites. So here we can see that the metal is bound to 2 ethylene diamine and 1 C2O4. So ethylene diamine, there are 2 ethylene diamines, and ethylene diamine is a bidentate ligand. It is a bidentate ligand. So 2 ethylene diamine means 2 into 2 binding sites. So 4 binding sites for this. And then 1 C2O4. It is also a bidentate ligand. That means 1 into 2. So 2 for this. So total number of binding sites will be 4 plus 2, that is 6. This is the coordination number of the metal. Coordination number of the metal M. Now we have to find the sum of coordination number and oxidation number. So oxidation number plus coordination number equals to 3 plus 6, that is 9. So answer will be option number D, 9. Next question is again from coordination compound, and the question is the hybridization involved in complex nickel CN4 2- is atomic number of nickel is 28. So here nickel is in its plus 2 oxidation state, so its electronic configuration will be 3d8. Okay, now let's draw the orbitals. We have 3d orbitals, so 5d orbitals are there. 1 2 3 4 5. This is 3d orbital. Then this is 4s and this is 4p. So 3p orbitals are there. Okay, this is 4p. Now we have 8 electrons. So it is 1 2 3 4 5, then 6 7 8. Okay, like this. But here nickel is attached to cyanide, and cyanide is a strong field ligand. Okay, so due to the strong field ligand, the pairing of electrons will take place in the 3d orbitals. So it will be something like this. 1 2 3 4 5. 5 orbitals are there. So all the electrons will be paired up. 1 2 3 4 5 6 7 8. So only one d orbital will be left. Okay, then one 4s orbital will be left, and then here all the p orbitals are also empty. So here we can see the compound is nickel CN4 2-. 4 cyanides are there. That means 4 binding sites or 4 orbitals should be there. So one 3d orbital is empty, then one 4s orbital is empty, and 2 more orbitals are required. So these will be taken from 4p. Okay, so d, then s, then p2. So it will be dsp2. That means option D will be the correct answer. Next question says the name of the complex ion FeCN6 3- is. Okay, so here the ligand is 6 in number. Okay, the number of the ligands is 6. So we'll write hexa for that. Now the ligand, that is CN, cyanide, is present in the anionic complex, because here we can see a minus charge is there, and we know that when the ligand is present in the anionic complex, then the suffix ido is added to it. Okay, so the suffix ido will be added to cyanide, so it will become hexacyanido. Hexacyanido. Now iron. So let's find out what is the oxidation state of iron here. The complex is FeCN6 3-. Suppose the oxidation number of Fe is X. The oxidation state of Cn is -1. So here we have 6 Cn, that means -6. So X minus 6 will be equal to the overall charge, that means -3. So X will be equal to -3 plus 6, that is +3. So iron is in +3 oxidation state. So it will be ferrate. Okay, hexacyanido or hexacyanido ferrate. And we'll write the oxidation number in Roman form 3. So it is hexacyanidoferrate 3 ion. Now let's see which option is correct. It will be option number C. Okay, hexacyanidoferrate 3 ion will be the correct answer. Now the last question is number of possible isomers for the complex cobalt En2Cl2Cl will be. En means ethylene diamine. Okay. So let's check. This is cobalt. We know that cobalt can form 6 bonds. So 1, 2, 3, 4, 5, 6. Now first we'll try the cis form. In cis form, similar groups are present adjacent to each other. So En2, two En are there, that means two ethylene diamine are there, and we know that ethylene diamine is a bidentate ligand, so it will take two bonds. Okay, so this is ethylene diamine, two bonds will be formed with it. Then next ethylene diamine, two bonds here. Then two chlorine are there, so this is one chlorine, this is another chlorine. So this is one of the cis forms. Now if we try making the mirror image of this form, then it will look something like this. This is cobalt, 1 2 3 4 5 6. Okay, so its mirror image will look something like this. En here, then another En here, and two chlorines this side. Okay, so this is another cis form. Okay, so two isomers we have got. Now we'll try making the trans form. Okay, in trans form, similar groups are present opposite to each other. So this is cobalt, 6 bonds are there, 1 2 3 4 5 6. So suppose chlorine is here, another chlorine will be here, ethylene diamine this side, and one ethylene diamine this side. Now if you try making the mirror image of this, it will look exactly like this. Okay, the structure will not change, so it will be considered as only one isomer. So total number of isomers that are possible here is 1, 2 and 3. So option B, 3 will be the correct answer. Okay, so here we complete all the chemistry questions from NEET 2015 re-exam. We'll be back with another session soon. Till then, keep learning, keep scoring high. For a better understanding, I would suggest you to practice same questions from our website www.examsnet.com, and for more information, please download our app from the link given in the description box. Thank you so much.